Hello. Look at this. What is that? This is my best microscope. What is that? Mm. Hmm. Why is it doing that? Doesn't look good. Multiple ways. Like it looks like I tried, but I didn't. So, what could it be? Oh. So today, I want to try adding lifetimes to a static library and see what happens. I have an idea of what to do. Did I call it Euster 2? Oh, I see. I was making something new. You know, this, I can just do it in there. FFI friendly. 2 years ago. Interesting. 8 months ago. 6 years ago. Interesting. The text history is rich. So check it out. This is a non-null pointer. But what I can just do instead is, this is new, I added this. So I can make it a lifetime and just like a normal reference. And then I break the entire library. But partial. Oh. Yeah, so my idea is that the global string cache becomes a local string cache. And then that's great. Yeah. All from string. So you see, you can't actually have nice things. Hmm. Const. So basically, this function should live on the cache guy. Mutex guard. Lock. So I was thinking like the Euster library would have like local Euster inside it, or like it would be backed by a local Euster, and then you implement global on top of local. Someone. Or maybe that's okay. Maybe this goes like this. Static. And then it goes like, ooh, CFG feature equals global. So, and then we have features. Where do you put features? I don't know. Badges. Real? You can just do that in the repo? Is this new? Holy moly. Let me look at another library. Who did this? Feature. Got no new notifications. Very sad. Feature. Is that feature? Got rid of all the features like a gamer. History. Features. So that was just like right at the bottom. Oh, smoke. Okay. Well, don't you want it to be like here? Why is there two? What? Why did that backspace the whole thing? Okay, global. And then you say default equals global. So, and then you have all of that. FFI. Torque. Doesn't it make more sense to represent that as a axis angle or something? Or you can make it bigger than 2 rotations. Oh. Yes. So. Okay, so this guy, new unchecked, insert. So this guy will have to change. Oh, goodness. Insert the given string with its given hash into the cache. So self. How do you know? Because like there's the lifetime of the reference and the lifetime of the object. I like okay, I don't know. I don't know. I do this. And then just unsafe. As ref. So I want as ref, but like string cache entry. Mask and hash. The stream is buffering. Oh. Did the... No, it's working for me. Yeah, no, it's working. I don't actually know what I'm doing here. Get existing. So is this guy... Oh goodness. Pub create. Okay, yeah, it's not actually supposed to be public. Why would you call it get existing and not just like get? That's pretty silly if you ask me. So I'm confusing myself. So, okay, well, this is like internal type functions, so we can just leave it. So this guy, lifetime, this guy, and this guy goes here. Slice. Shh. Got a world record in surf. Some world records are more valuable than others. But it definitely takes a lot of work regardless. To either like find one that can be beaten with some grinding or to do the amazing amount of grinding to beat like the big ones. Well done. entries. Okay, so I see. Okay, I think I understand what's going on. So it grows the mask so that the hashes don't collide. Yeah, is that what you're doing? Oh look, string cache shows a vec of pointers to the string cache entry struct. The actual memory for the string cache entry is stored in the leaky bump alloc, and each alloc is rotated out when it's full. And a new one twice its size is allocated. Okay, I was wondering about that. The allocator memory is never freed, so our strings essentially have a static lifetime. So my goal here is to make it so that they do not have a static lifetime, so that you can drop the string cache thing. There's a diagram of the underlying memory, which great job. I also think it'd be cool to drop this. Okay, so proper alignment is guaranteed when allocating each entry, as the alignment is baked into the allocator. Okay, so it always is 8-byte aligned or 16-byte aligned or something. String cache is responsible for monitoring the allocator and creating a new one when it would overflow. Yes, the alloc itself will just abort if it runs out of memory. Awesome. We abort rather than panic because the behavior of the spin lock in a case of panic while holding the lock is undefined. Buh. Okay, Fred safety. Only access string cache through the spin lock in the lazy static ref. Oh. I see. So we don't actually need that for our case because it will be an owned guy. But we can still implement lazy static ref for the global guy. So it's got a what, double lock? But the initial capacity of the capache is the capache evenly align 128. Size equals 128. Needs drop. What does needs drop mean? What the hell? 20% performance improvement? Bruh. Hey, world record is world record. Yep. Do you already have world record approval? Got the world record badge? Is it a badge? I don't remember what Roblox. Who's Roblox? It. Like, is it the lifetime of the individual reference? Or is it the lifetime? Because, like, this guy doesn't have a lifetime on it. Mutable. I am confusing myself. How do you make a pointer into a reference? I feel like the lifetime should be inside of this guy. But I don't actually know. Let's see if I wonder if I can make a test to mess around with that. Wah, 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 wah. Okay, so I'm gonna need to make a guy. And then, how about I'll even give it a little thingy with things in it. Um, uh, huh? I don't know if I'm gonna be able to do this. You kept taking it from me. My world record in low gravity. Without on what? Low gravity was April Fool's 1 year, right? Game? Why is the game? Oh. Get. Oh, obviously. Oh. I believe it's like this. Okay. Oh. Well, I guess I was wrong. As ref. Wait, what? What? Why do you need to do this dance? Okay, stay. Give me that. So this is valid. Okay, so that makes sense. Hmm. Mutt. Okay, so I think I'm gonna run into the problem, the fundamental problem, where like you want to take a immutable reference, but then you also want to take a mutable reference. So if you give back a lifetimey value that's based off of this mutable reference, then the reference can't die, rather than the object can't die. Methinks. I'm just gonna try and like implement a little toy example here. With something simpler. So what about if my indices are like integers or something? Cause like, so this guy always happens. What? What? Why didn't it say anything? Hello? Can I have an IDE? Okay, string to start. Failed to load workspaces. What? Workspaces? Why? Okay, it's hot. I'm gonna open the window. I don't know if I can even make a little toy example here. Like, I feel like you kind of got to do the full thing. Okay, so entry string. Okay, so we don't want it like that. We want like get or else, unwrap or else. I don't know. Google. Right, because there's no value. Oh, wait. Subset, superset. Cool. Replace. Take. Whatever, it's just a thing. Insert to owned, and then semicolon, and then get unwrap, I guess. Something like that. Why is it value? What's up? Mutable because it's immutable. But this is the none case. Okay, so I just have to do this then. Wait, returning this value requires, but can't you drop it at the end of this little scopy scope guy? What if I make a little scopy scope guy? What? Okay, if we return here, then we're out, and this doesn't need to run. So why is the lifetime still held? Okay, I guess I'll try something else. Hello? It's kind of nasty. Like, all of this should be one swoop operation. One swift operation. But, like, it's clear that I don't really understand what's going on. Because I'm not sure if this, okay, this is, I mean, based on the syntax, it looks like it means that this reference is valid for lifetime A, rather than this object is valid for lifetime A. So then, like, for the return value to remain valid, the reference must continue to be held. And when the reference is dropped, then it is not valid. So let's take a look. So let's do like no, what the hell? Alright, the guy is too long. Okay, and then we do like So if I do like this, and then I do like I, this should fail. Oh. Oh. Yeah. Okay. So it said mutable borrow occurs here, immutable borrow occurs here, and then the borrow later is here. So it goes like, yes, I'm taking a reference to this guy. And then this one goes like, yes, I'm taking a reference to this guy. And the lifetime validity returned is based on the reference taken rather than the object itself. I'm trying to figure out if it's a like distinguished gentleman, if there's actually a difference. So like the thingy needs to be borrowed mutably and immutably, but the lifetime doesn't come from taking that borrow. The lifetime comes from where the data lives. So it'd be like, hey man, I live for A. Ooh. No remix. Let's go. Oh, jeez. That I've ever seen. Okay, so we go like this. And then not real, not real, not real, not real. And then it all comes from the guy. Lifetime may not live long enough. So I am... I'm getting at what the hell going on in Miami, bruh, right now. Okay, so the method was supposed to return data with lifetime stir, but it is returning data with lifetime 1. So this guy is 1. So I think I could fix this by going like, yeah, this. So I could go like, oh, there's some lifetime that lives for some amount of time where stir outlives A. I might have got it backwards. Okay, where A outlives stir. Yeah, okay. So if I say yes, if I say okay, the reference I'm taking, I actually need you to be quiet. So if I say the reference I'm taking outlives the object's lifetime, that doesn't actually make sense. Why? How can the reference outlive the object? Right. So this is actually equivalent to how the code was before. It doesn't actually help. It's just the same thing. T. So this implicitly says take a reference to self and give me T with the same lifetime. Not feeling too smarty right now. Lifetimes are tricky. Get Oh my god, it goes so deep. All right. What if Okay, I think I understand. So when the type signature is this, you create a new lifetime when you take the borrow of the object. So right now, this guy is entirely owned right here. And then when you do this, you're creating a new lifetime. But that's not the lifetime I want. So I would need to do some fancy schmancy bing bong nice spelling. Okay, let's say let's say I have a array of 4-letter words. Buh. So the thing is, like, I can't use like hash set or other things as an example because they use the lifetime of the reference you create. But I want to say that the reference you get back is valid for the entire lifetime of the data, even if you drop the reference to the object containing it. So I need to like have stupid functions that do stupid things. So we go like let's do something stupid like that. So oh. Generic self types. Okay. Okay, so that's not real. We don't do like that. What is this? What do you want? Partial eq. Oh, I see. That's at the bottom here. Okay. So, new. So we get a this guy, and outcomes of that guy. Maybe it might kill you. Surely. So we do like this. If s length equals 4, some self right. Can't do like to own because that'd be like a vec. Whatever. We'll just do R. I'll just and like it just literally does not matter. It actually straight up does not matter. So mutt copy from slice s as bytes. Surely. Ass. Else none. So we check if the length, if it's a 4-letter word. So I'm like sidestepping all of the like variable length shenanigans going on in this business. So it's a bunch of 4-letter words. So when you construct it, you always use a valid string. So it always contains valid strings. So then get these nuts. I guess we can say as stir. How do you coerce? Can you like deref? Bro, am I smoking? Like what? Give me Can I have an IDE, please? Um, unsafe function fair. Um, safety. The bytes were constructed with a valid string. Haha, I'm safe. I am not super sure about that, but haha, yes. I'm gonna do a bunch of unsafe stuff. So this guy is a guy that does stuff. It's a guy. It goes like, I'm the guy. Words, I guess. So the idea, what's the idea? What am I doing? I'm trying to make a like proof of concept where, oh gobbledygook. I need interior mutability. Where where I can drop the reference to the object, but still have a valid reference to data in the object, as long as I don't drop the object. That's what I'm trying to go for here. Is instead of like sort of nesting references to the object, I want to go straight to the top. And like still have it be valid Rust. Ugh! So the idea is you would be able to gop. Okay, let me write the ga. Let me write the code. So I go like this. I go like create a scoped reference to words. And then we do like, oh, words equals words, the words, sword. We can't use sword actually. And then get a word. Get a words. Words dot get. No way. Bruh. And then, like, is the borrow checker gonna try to be smart, or like I don't know. Drop the scoped reference. I guess I could check against a different implementation. Yeah. That is correct. Okay. So I have no idea. I have no idea. Segolek. We don't do like this. We do like this. It's not real. Okay. Literally. Actually, straight up scan. Okay. Self.storage. Scan. Enter. Okay. This is like, once again, implicitly grabbing a reference. So I necessarily need unsafe. I can't. Yeah, so you see the chain here is that this is borrowing this object, and then that comes from here, and then this is borrowing this object, and that comes from here, and then this is borrowing this object, and that comes from here. So it's like it's like this nested chain of references. And then it hates me because, okay, hold on. The lifetime is wrong because we're returning data with a long lifetime. You can't be doing like that. It don't be doing like that. It don't be. Because it's not the same thing. So what if, can you do like this? It doesn't try to deref? Hold on. Eek? Ah! Deref. So I guess I just kind of go instantly unsafe. And let's go. Easy clap. And then, so I said, I promise that this thing is going to live for stir. I promise. I pinky promise. I pinky swear. We better hope that's the case. Boy. So now I guess we can literally just paste the exact code. Oh, semicolon. And then if my good guy does not exist, then then what happened? What happened? Who did this? How could you let this happen? Panic. And then we go like new word equals to 4-letter word new s unwrap. Then we go like self.length self storage self.length equals to new word, new world, and then self.length plus equals 1. And then am I allowed to do this? Hee-hoo. So I don't yet know what the hell is going on. That's what's going on here. I'm sort of exploring the possibilities and seeing where things fall apart. If I do get, do I die instantly? I don't know. Ah, C. Yes. So this is doing separate borrowy borrows. So it's borrowing storage and length separately. So it has to borrow this mutably while borrowing this immutably. And then it transforms it into a different lifetime. It says that you live forever. Instead of being based on the lifetime that was, oh look, it compiled. Oh my god. Okay, what? Okay. So if it's, okay. Everybody calm down. Everybody calm down. Okay. So if I do this, backing space. Oh no. Okay. Okay. So does it run though? Okay. So this is like Rusty Rust. It's saying, oh, I don't know. Okay, it's saying that we take this lifetime when we call get, and then that is attached to the steering. But when I have this guy, it's like no. This lives for words. Word, you get it? And then so that changes this when I save the file, because my little scoped borrow gets dropped, but because I said it's stir and not based on the reference we just took, so like this is the reference we just took, or when you call this function, it's based on the top level. It's unsettling. I've been programming Rust for a year, and this is unsettling. But like, I'm trying it out. You know, we're testing things out, seeing how it goes. So the lifetime of the object is not actually how Rust works. It's all based on the lifetime of references to objects. I'm thinking maybe it exists. Well, I mean, it probably has to exist in the compiler, but by saying this, I'm explicitly saying there is some lifetime stir, and because it's part of the object, it has to be valid while the object is valid. And this is a zero size data structure. It only exists at compile time, but it's representing the lifetime of words, the data structure. So then I go like, I put in a word, then I scoped reference, drop the scoped reference. It looked like it was good. Wait, why is this allowed? Isn't that? Oh, it's a stir. Oh, okay. Okay, so what happened when we do it? Cargo run release. True. Okay. So in this specific case, my assumptions appear to hold. Or at the very least, it is failing in a way that looks like my assumptions hold. Who knows, really? It's unknowable. I'm just gonna have to. So what? Okay, what? Okay. Yeah, no. Okay, we can't do this. So I have to go to like. Okay, if we do like, another one, it's not allowed. It's not allowed. You can't do that because, oh wait, what? Oh, is that all you need? Do I not need interior mutability? I thought I would need interior mutability. All right. Uh, is this death? Am I dying right now? Okay, actually, let's see. Let's see. What if I change the way this looks and do number D? Get huge, insane, unwrap, and then wow. So this is functionally the same as this. So now the question is, what happens when I drop words? So I got a scopy oopy doopy right here. I'll make a little scope. And yeah, this obviously doesn't make sense anymore. But like, okay, so let's see. Let's if I go like this, let equals to this, and I get rid of these scoobert dooberts, and then I go A B. So now I think it will kill me because words is dropped at the end of the scope, but it says that the lifetime of this guy must outlive the lifetime on this object, this thing. So I predict that I've written the code correctly, and it will say lifetime problem. Uh-oh. Uh-oh. Oh no. Oh no. Oh no. Why does that compile? Oh no. I think I've just created UB. Undefined behavior. Let's see what happens. I think it'll print what? Is it seg fault? Is that when you access memory you're not allowed to? Okay, is it being no, it can't be. Cuz like if we do this, words is declared here, mutable borrow. Okay, what if we don't do like that? What if we go like, hey man, crap. Yeah. All right, let's just shush for now. And we'll do be doing like this. Oh my god, I have to copy it again. Ooh. Does not, yeah, this is what I was expecting. So it says words does not live long enough. I don't get it. I don't get it. I don't get it. Why doesn't it kill me instantly when I drop words? Because is it because it's the same lifetime? Okay, I remember seeing this thing where you can go like where self like this. It still doesn't help. It's valid code. Self outlives stir. Okay, what about like this guy? So this is deeply unsettling. I am not understanding something. There's something that I don't understand, and I'm gonna have I do have instant undefined behavior right here, because like I'm dropping something that I am holding references to, and it's not giving me a compile error. It should definitely give me a compile error. Definitely. So in this case it works, but I am pretty sure it's just because of like memory clearing semantics that the memory just so happens to not be cleaned up yet because like it didn't need to, or like, yeah, more like it's a dangling reference and like the memory wasn't taken by someone else yet. So like it was like cleaned up. It's like, oh, I don't need this anymore. But then it wasn't, it just happened to still have the same value. That's what I think is going on. Is it's reading memory, but like, okay, I see. Because like, okay, so the internal allocator, the Rust standard allocator, still, the memory is still part of the segmentation owned by the Rust allocator, but it's not in use by anything in the program. So it's not a segmentation fault because it wasn't like freed. by the process. I don't know exactly. But if there was more code in between there, so if I went like, oh, calculate pi to 7 million digits, and then I tried to do this, it would possibly overwrite the memory that it's pointing to, and something else would happen. It probably would just say false in this case. But UB. So I don't know what even is be going on. I don't know how to say words lives for stir. And when I drop words, make sure all of the references to words are dropped as well. I thought that's what I was saying with this code. But it turns out that is not what I'm saying. So, huh? What? Ugh. So I use this trick in the do I have the thing open? I use this trick in this one. In this one. This one. So I had this, where's the... Where is it? Self. Runnable. So I'm using the same... Oh. Oh. That is different. Okay, let me try that. I think I just wrote it wrong. Let's see. Compile error, please. Okay, let's try this. You create a when you call new. Woo. Oh, self. Oh my god, okay. Damn it. Give me a compile error. Please, my entire idea depends on this. Ah! Wait. Am I stupid? Size 8? Am I stupid? Size 24. Size 0. It's supposed to be a 0 size type. Oh my god, bro. Alright, do I have this anywhere? Oh my god, bro. This worked when I did it before. So, like, what is going on? So I said, I said, here is a runner. You can run this runner. You call... So I'm a runner. I have like Lua scripts and stuff. I have a Lua context. I've been initialized. I'm a runner. Then you can say run a bull. So you give it the Roblox DOM with a lifetime. You introduce that lifetime, and then it creates a run a bull. And the killing bit, the like scary thing is that it's moving, it's creating a reference to this guy inside the Lua, and that must be valid for any time you try to run the Lua. And I tested this. So it creates it, woo, and then now you can run scripts, woo, and then you see what it's doing is like, oh goodness. Okay, like inside the scripts, it's like reading the DOM. And then when you drop it, it removes the DOM. Drop. Okay. What if I do this explicitly? Let me try this. Maybe I just am not explicit enough. Let's see. What if I just say drop words? I don't get it. Why is it valid? Is it like... Is it doing like magic lifetime solving and like... Yeah. What if I go like this? Maybe this is a little bit different. So now words is definitely dropped. For sure. Missing lifetime. Got something wrong here and I don't know what it is. But deeply unsafe. It wasn't supposed to let that happen. No. Okay, look. Think. Okay, so where's the code where we do be using like this? So let's find this. Oh. I don't use it. Okay. Run script. Okay, so we create a runnable context, run a script. Watching this. So if I go like, oh, no. Okay, that's just the... If I do this, drop context, it says, wait a second. You said that you want to create runnable with a lifetime based on context, so that lifetime must be valid while runnable is in scope. So you tried to use it here, but it was dropped. So this is safe, and I'm struggling to figure out how this is different. This seems correct. I'm struggling to figure out how this is different. Okay, so I have some value that's somewhere else, and I'm like, here, this is a reference to that value, and then I'm making a fake static reference, as long as the reference that is real continues to exist. So that is like a different scenario than we just got a thing and like we're saying this is some lifetime that's associated with the object. There's no data elsewhere. Oh, good. Oh, good. I can't believe I did this wrong. That's horrible. All right. Any other ways to place phantom data? T. T. Right. Yeah, okay. We save 8 bytes by moving the reference inside the phantom data. That was stupid. My 8 bytes got 8 bytes back. I am going to actually commit that. I don't think you can. Let's see. I don't think you can do this. This doesn't make sense. Remove the unnecessary generics. This takes 0 lifetime arguments, actually. Yeah, okay. I think this worked. Okay, that was weird. I don't know why I did it that way. I'm curious about the history, actually. So it is a different scenario. Like you actually have a lifetime to work with. Whereas in my prototype here, I'm just kind of constructing a lifetime based on nothing. And it says, oh, this works for any lifetime. Yeah, it works for any lifetime. Critical thinking skills. Like Scoob. We need to do some critical thinking. I can kind of see the problem. Like, the lifetime isn't really like attached to anything. It's just kind of like, oh yeah, there's a lifetime. And then it can decide to be whatever it wants. So if I say, oh yeah, it's good outside the function, then it's like, cool. That fits with any lifetime. But I want it to be the lifetime of that guy. All right, so I think I might be missing something here, and I have an idea. So, like, based on my other code, where you're like, you have a lifetime from somewhere else, let's make some idiotic struct that we have to take a lifetime to. So let's say struct liver or something like that. Let's see. Lifetime host. So this is a lifetime host, and like, then this becomes a reference to lifetime host. And then, oh goodness, oh goodness, oh goodness, oh goodness. So when we say new, we grab, oh goodness, oh goodness, oh goodness, oh goodness. A reference to lifetime host. Host. And then I go like host, lifetime host, and now it breaks. Oh, so now it breaks because now we're dropping host. So this is what I want. There's got to be a way to do this without this stupid stuff. Oh my god. So look, watch this. So host is created within this scope, and then at the end of the scope is dropped, and that's what the compile error is saying. It's saying, oh, your guy doesn't live long enough. Watch this. If I move it outside the scope, no problem. And so what I want is that this is not real. And then I want this to fail to compile. And then this does not fail to compile because the words itself should be its own host. Yeah. I don't know. I don't know how to. I mean, this works, but yeah, I don't know how to do this. Oh, excuse me. Um, critical thinking. Yeah. So, okay. So I think I have all the pieces here. I have all the pieces, and I think it can get a lot simpler. So like we shouldn't need this. We may not even need a lifetime on this itself. Okay, wait, okay, what if okay, let's try things. Okay, so this is like, prototype. I have an idea. Prototype. So this is now the working prototype. Euster prototype. Protoi. How do you spell? Cool. And then we go like, nah, and then words where words stir self. And then we go like, that's a new one. And then we say like, yo, yeah, self. And then none of that. And then none of that. Damn it. So usually it works because I think this is valid. So like, the strings that it returns remain valid because it never overwrites the old ones. It's append only. So if you get a reference to some memory location, then as long as the object remains alive, that will remain a valid reference. And then you can hold mutable or immutable references to the underlying object because it's append only. So you can just, as long as you don't take them at the same time, like as long as you don't take two mutable references to the same object at the same time and try to add two words at the same time, then you're good to go. But how do I introduce this lifetime right here? So when you create it, this needs to wait. Can I say like plus stir? So usually it works in Rust because it's chained, like we saw earlier, where like this is a stir. Oh goodness. And wait, oh goodness. Wait, what? Coerced to double stir? What? Okay, what I was saying, this is a stir, and it holds a reference to word, and word holds a reference to storage. Storage holds a reference to self, and then self gets that reference from when you call this function, it takes a reference of this self object, and that is right here. So when you call this function, it goes dunk, 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 and you get a reference like that. But what I'm trying to do is instead bypass that system Okay, how about I wrap it? What if I wrap it? Okay, so we go back to working code. And we make this function do everything. So we're gonna go like I don't know. So words, lifetime host. Oh. And it's self-referential. I can't really do that. Okay, whatever. I'm just gonna like see if I can even do it. Okay, so wait. So we're gonna go like new. That's how it does. Do be doing it. So it goes like self. And then it goes like, oh, actually, this has a lifetime, doesn't it? So we go like, oh, what's up? I'm this guy, wrapped. And then we say, yeah, so I have no words. It's nothing. They're none. And I have this lifetime host. And then we say, well, oh, hold on. So let mutt equals this. And then we say, okay, well, now we have a lifetime, so we can go like, hey, man, self, oh, no, wrapped dot, words put, oh. Can you do like, do you have to do replace? What if I don't care? I guess it is replace. Okay. So I'm gonna do words. New, 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 new. Wrapped. I think this might not work. Dot life, because I'm gonna move it out. Cool beans, and then I say yeah, and then it's gonna be like, okay, here's what I think is about to happen. So I have this thing, I'm the guy, and then it doesn't have any words, but it has this lifetime already in the object, and I did that so that I didn't have to move it later, which would invalidate this lifetime. And then I put words into it based on this lifetime, and then I move it out of this function. So I think that this is invalid because we're holding a reference to an object in the data structure. So we're doing move while holding a reference. Yes, so it says, hello, I'm declared here. I am borrowed here. Cannot move out because it is borrowed. Okay. I'm not gonna lie, I'm kind of out of critical thinking, and I want to go paste it into ChatGPT and see what happens. Unless anyone else has other ideas. I tried. Like, I wanted to do that like half an hour ago, but I'm like, I gotta hold on to my critical thinking skills. But, oh well. How can I implement this without a lifetime host? Hopefully it like... The core issue with your current design is that you're using a phantom lifetime tied to external lifetime, but you're essentially trying to say that strings return by as long as the word starts out. That's exactly what I'm trying to say. The use of lifetime is to attempt to externalize lifetime control, but doesn't add safety or clarity. In fact, it complicates and requires on-site transmuting. Remove sure that return references are simply tied to the lifetime of self. Yeah. 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 So this doesn't work because you're creating this lifetime, so you can't. I want. So like this is like, this is a compile error now. Because you're holding a mutable reference, and then you're also holding an immutable reference, and then you're dead when you try to do this. Oh, actually, it's just fully invalid. True. So it identified the key issues, and then it just made up something that doesn't make any sense. I was a little bit excited for a second there. How do I change my prompt or do I? I think this bit can like get lost. I can try to make it a bit simpler. 4-letter word. So like, I could just say that it's some static stir. I think that's okay. If I just go like, nah, and then this is just static stir. But like the whole point is that it's not static. I guess I could do like string. He who string new. Uh-oh. That's not gonna work. Okay, what about... Is there a... There's no macro. Oh my god, bro. Alright, how do you do this? I think you can go std array from function and then string new. Oh, I can actually pass that function. Oh, I see it once. It's one. Okay, I see. Unlucky. Okay, so I've removed like the nonsense. So new word, we just do s2 owned, and that's it. And there's no need for that garbage, and it doesn't take up valuable token space. I should have just done this from the beginning, but I was like trying to figure out what to do. Okay, that is way better. So string, we can probably just do this, eh? Aster. Hee hee hee. Okay, so what if I annotate the code? Grow only list of words. Okay, it's a lot more focused now. I don't have the giant thing that's the like 4-letter word. I just like uses heap allocation, but like whatever. It's a demo. Okay, how about how do I do this? So, oh my goodness, what? Okay, how can I implement this with a lifetime hold? I want to have it so that I want to think about what I want. So the goal is, I want the returned structures to be valid only while the top level structure is valid. I want the returned stir values to be valid only while the words structure that they refer to is valid. I don't want to attach the lifetime of borrowing the words structure to the returned strings. Values, I guess. How can I do this without the lifetime host trick? No way. Phantom data, no way. So I can get rid of this as well. The little example at the end here is not good. So I think I'll get rid of it. So so I want like a compile succeed and compile fail of like dropping words here should introduce a compile error. With a correct implementation. Dropping words should choose with correct implementation, the fault code should be valid. So, yeah. Okay, so we got a little bit more explanation in the code itself as well. Please, ChatGPT, please give me the answer. I surrender my critical thinking skills. I'm gonna go get a coffee, or heat up my coffee. Never mind, I'll have the rest of that nasty coffee tomorrow. Okay. You're on the right track! Trying to model the structure, to own the data. You don't want to tie the output. I know. You don't want to use tricks like lifetime host. Borrow from storage. Melody when it's dropped. Natural safe way to attaching lifetime. The word struck to the return references. What? It's just going to do the same thing again, isn't it? Nope, you can't do it. This is invalid. This one takes a mutable reference to words, and then that lifetime is now tied to A. This one takes an immutable reference to words, but wait a second, you already have a mutable reference, and in Rust you can't have a mutable reference and an immutable reference at the same time. So compile error, right here. Or rather, it happens when you do this because it recognizes that it could potentially drop it. But when you do this, then it's like, oh, I need both. And then you can't do that. So it can't see the issue. What? Do what I want. Okay, what if I just say your main function is your implementation does not follow the outline. The main function will have a compile error since intern, I'm going to do the and get takes a mutable and immutable reference simultaneously. This is what I am trying to avoid by using a grow only structure and returning references with lifetimes directly tied to the top level structure rather than being tied to borrows of that structure. So it's the brilliance of Rust. Yes. Specific borrows, yes. In the same scope, yes. The only way to achieve this is by tying the return lifetime of the by tying the return lifetime to the lifetime of the word structure itself. Transmute is definitely unsound. There's nothing enforcing that stir matches the real lifetime of the string storage. Let's do this correctly. That paragraph gives me hope. Correct design with a check mark. No way. So, oh, a stir. Stir? Um. So this is a compile error because there's no way to tell A is good. Yeah. So this is the first code that I wrote. It looked exactly like this, and this is like upcasting lifetimes. It doesn't work. Stir. Why did I put stir? Phantom data is how we hold strings that live as a save. ChatGPT. I surrender my critical thinking skills to the machines. So this is basically the first code that I wrote. And it doesn't work because like that doesn't make sense in Rust. And then like if I transmute it to force it to work, then we still don't get this correctness. This is unnecessary because it doesn't meant to do this. Yeah, so, yeah, okay. Look. So, but before I do this, this is, forget about 4-letter word. Oh. Okay, and then we paste the ChatGPT version and it dies. Self. Yeah, you can't do that. And shocking. It may not live long enough. Oh, really? So this is like valid Rust errors. It's saying like the data may not live long enough because I could if it allowed this code to compile, it would mean that I could, in some sort of code somewhere else, sneakily change the underlying storage in a bad way and make this reference no longer valid. So by tying this lifetime to that lifetime, it means that I'm not allowed to do this. I'm not allowed to take a mutable reference while this immutable reference is valid. So this is not allowed by the nature of Rust. But what I want is to promise. I want to say, I promise I won't mutate the underlying thing. So give me a chance. Yeah. All right. Well, let's try it. This is like exactly the same, but completely different. You don't actually need transmute, you know. But then we don't get the compile error like we want. This should be compile error right here. This one is okay. This one is not okay because A and B refer to data in words. So if we drop words, we're done. We're pooped. It was so promising. Can I just like try again? This is only on sound if you lie about it being static. It's not static. New marker. Oh, look at that. Huh. This is kind of like revealing internal implementation details type business. It goes back and forth between like iter find map. It just does not believe that it needs to transmute. It doesn't believe me. It's like, nah, that's valid. Nah, that's valid. Now it works. No way. Scope. So yeah, this is just the same lifetime host thing. And like, this is not correct because the lifetime host is not dropped. So this is not a compile error. This is just exactly the same code that I already wrote, except wrong in multiple ways. I am curious though. What happens if I do this? I think, okay, what I think will happen is it'll say, oh, the borrow is dropped somewhere, somehow, like within this scope, for example. I think it'll complain that it dies instantly and it's what? Oh. Okay. So, yeah, I don't know. This is what I want. but when you drop words. I want this compile error without needing the lifetime host. Don't know how to do that. I don't know how to do that. That's what I wanted to outsource my critical thinking skills for. Could it actually just be impossible to do that? That would be unlucky. I want to teach Rust about my thingy. What do we need? Like associated. It understands my requirements now, or like the words implies understanding of, or seems to indicate, I guess, the requirements, but then it fails to meet the requirements. I'm really digging down to the underlying issues before I try to rebuild everything. All right, try again. Try again. Just do it again. Mm-hmm. 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 Highly unsafe, as you've noted. Do this soundly. It really likes stir. Oh, it identified this. Promote to the shorter lifetime. Extend lifetime. Is that hallucinated? The storage outlives A. Oh. It's interesting. Yeah. So like this is an unsafe function. Well, it actually recognized that it needs to do that now. So that's different. But it is once again literally just the same code. And we don't get this. Well, I think this would actually compile now. But is it... Okay, it really doesn't like that. As stir. Where's the thing? T. Sized. Okay. Question mark? Oh. Consider removing. Is that a compile error? Why does it say consider? Implicit sized. I guess. Alright, now what? Lifetime may not live long enough. Did it get it backwards? No, that makes sense. If we do it like this, I think it'll go away. But we still... Oh, hold on. Damn. Oh, wait. What the hell? Damn. Stir. Not so sure. Long outlives short. Oh, interesting. That makes sense. You can grab this right away. Is there like a... I don't know. Word. Using A or B after this would be undefined behavior. I want to upgrade that to compile error rather than undefined behavior. Because, like, yes, it is UB. So let's make it not possible. Oh my goodness. It's interesting that the responses I've gotten have been quite varied. It does seem to consistently get what I'm trying to do, but is it like too generic? Like, okay, what I think is happening is that this is a generic. And it's fitting the generic to the full scope where it's accessed. So it's like the whole scope. It just goes, because like it sees, okay, it's used here, it's used here, it's used here, it's used here. There it is. There's the generic. But I want it to end here. Don't know how to express that. This is the core of the problem. This is the core of what I'm trying to do. I didn't actually realize that I don't need interior mutability to do this. It's kind of exciting. I can like ensure that you don't hold immutable and immutable borrows at the same time to the overall data structure with just the borrow checker. But then because the data is like write only, write only and read only, grow only, and then immutable, it should be safe, I think. And then we can like skip all of the locking and skip. So instead of like locking, it just uses the borrow checker. And you can explicitly drop it. I don't know how to make this work. This function is cool. Like the entire point is that it is extending the lifetime. Hold on. Ouch. 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 Ah. Ah. Ouch. God. Sharp pain in the side. Let's go. What song is it? If You Want Me. Cool. Very fun. Thank you, buddy. Okay, why don't I use the search bar? You know what? Got it. I've heard the sample, or I've heard the do 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 do. I've heard that before. Wait a second. I can do a little bit better here. Copy. Insert stir. I need insert stir, but not sucky. Is there like a not indexed one? Extend. Push. P. Oh, I see. Cool. I think I want push. So no need to make a new string then. Just grab the existing one. Does it return anything? No. Okay. So what did I say that made it understand? How can I make you understand? Okay, the correction was what made it understand. I was just sort of attacking the failure points. How do I say it? Oh my god, bro. So like this is usable. If I have the like this version with the lifetime host trick, it's usable but misusable as well. So like you got to sort of keep them together, and you're not allowed to put them in the same data structure. So it just sucks to use. Bruh. Oh my god, bruh. Hmm. 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 Not quite. Hmm. Hmm. I'm like going through Euster design in my head. The diagram we saw, um, at the top of this guy. So I was thinking like, what if you had a data structure over the whole thing, and it's like a pointer to here, and then like you there's some sort of data structure. I get you. I see. So you could have like unsized. You could do it with an unsized data structure. I wonder if that would help with the pointer arithmetic. Curious. So you could make string cache entry. Instead of do like this, you go like, hey man, it's like stir, and it's unsized, and then everybody hates it. But then like, what? Add one. I see. So that's this guy. So it's like, shouldn't it be like, oh crap. So then you could like go like this, right? Ah crap. Eh? Okay, what do you want? Exact error. Okay, I know. Clone. String cache entry clone. So if you do like that, then you don't need the pointer arithmetic. Like I'm so frustrated about the lifetime thing. I don't know how to do it. What if you have like a borrow step? So you make the thing. Yeah, but then you can't have like mutable borrows. Eh. I saw someone online say that there's no such thing as the lifetime of the struct itself. And I'm wondering if that's like the foundation of the problem is that information is not accessible, representable. I don't know how to solve this, and I can't implement this until I do. It's an interesting problem. Get out of here, ChatGPT. Get out of here. Okay, so yeah, we'll do it if let's GG. Dropping lifetime host gives the desired compile error. Okay. Um, ugh. I think it's fine. So, okay. How do I? It should be like right here. There it is. All right. So I want a direct link. Oh, it doesn't actually go. Wait. This is just some goober right here. Okay, so I see. Okay, I see. Okay, so I'm saying this lifetime is the same as this lifetime, and so that's how it works. Okay. Because like it doesn't go directly into here or something like that. I kind of like that extend lifetime function. You're allowed to do that. So explicitly say I extend this lifetime. So transmute is like any to any. It is a wild function. So by clarifying that this is extending the lifetime, is doing a little bit of due diligence. So it's not like transmuting the type as well. It's saying the input and output types are the same. Caller must ensure that short lifetime is valid for long is actually. What does unsafe mean? It's like hold my beer. It's like, oh, look at that. The memory safety cannot be verified by the type system. So the idea is that Rust is restrictive on the type of programs that you can write that are guaranteed 100% to be memory safe. But there does exist memory safe programs that cannot be guaranteed by the Rust compiler rules. So as the programmer, you're saying, I guarantee that this code is memory safe, even though the normal compiler rules would suggest that it is not necessarily guaranteed. So it's like, I promise this is memory safe. Type pruning, punting. Okay, transmute is reinterpreting bits. But I'm using it to extend the lifetime, to say like, this data is borrowed from here. So words. So down here we have words. I do words.get. And this is a direct owned value. Whereas inside this function, it coerces it into a reference to self. So it's taking a reference to the words. And usually in Rust, what you do is you don't have this reference here, and it goes like, you took a borrow, so the data that this function returns is valid for as long as that borrow is valid. But what I'm saying is no. The data is valid for as long as the underlying type is valid. Which usually you don't do it like that. Usually there's this like chain of borrowing, and then you must drop the previous immutable reference in order to take a mutable reference, so that you don't accidentally mutate the underlying data. But like I'm doing unsafe because I'm promising that the way that I implement this, I promise that I won't mutate the underlying data while you expect it to not be mutated. I promise I'll keep it the same. I promise I'll uphold the normal rules, and I won't do anything that'll lead to unsound behavior. But I'm struggling to encode that in the type system in a way that gives me a compile time error like this. So I want it so that when I drop words, I get a compile error here. But instead, the best I can do so far is that when I drop the lifetime host, why don't I name it the full thing? I get a compile error like I want with words. I want it to error here, because this is undefined behavior, like straight up right there, undefined behavior. But if I make it error like this, then you're prevented from doing the undefined behavior. Yay, prevented. Oh my god. So did I do, okay, extend lifetime? No way. Safety. I promise not to implement to mutate the strings in the implementation of words. So, okay, so nowhere does it actually mutate the words. GG. Oof. Oh my god. I mean, it's kind of telling what's going on. Okay. Buh. Is this all for your Beehive client? In the end, yes, I guess, because like, God, what a tangent. So in the Beehop thing, I need to read Roblox maps. In the Roblox maps thing, they're using a library called uster, meaning unique string, to have a sort of deduplicated list of strings, and they're using it for Roblox properties. So like position, C-frame, blah, blah, blah. All of the Roblox properties, the strings are used again and again and again and again for every different object. So previously, for every different instance in the game, it would allocate a new string for every single property. Really slow. But what they did is they're using the uster library, unique strings, to go, oh, we already have an allocation for this, reuse it, no need to allocate a new string. And it's like 5 times faster. So outrageously good. But it's really easy to shoot yourself in the foot when you're using the library by like creating unique strings from user input. So in my implementation, I'm running scripts, and the scripts might try to access properties that don't actually exist. So if I just kind of naively allow the scripts to access properties, it will balloon the memory and eventually run out of memory, because it's creating a unique string And in the Euster implementation, it's never dropped. It's grow only. So there's like many ways to deal with that, but like it's a foot gun. You can misuse it by accident. You're not prevented from using the library in a way that is suboptimal. So like it's pretty much not a problem unless someone specifically contrives an attack on your code. Like running random scripts, pretty much fine. The only way, like someone would need to identify the vulnerability, write a malicious script that specifically goes and generates a bunch of giant strings and like pollute the memory. It's a targeted attack, but technically it's a vulnerability. It's a way to cause unwanted behavior and like denial of service if you fill up your strings while you're decoding around. It's like very specific. It's like in practice it probably wouldn't show up without being targeted. But like I think that I can do better. Intern static. Like, this is not even good, really. So this implementation of like grow only list of words that is droppable means you can reclaim the memory. In the Euster crate, Rust crate, you can't reclaim the memory. It's a global unique string cache. So it only adds to the cache and they're never dropped. What I'm trying to do is say that the strings are valid for a certain amount of time and then they're not when you drop it. But I'm struggling to make that happen, the when you drop it part. I can make it so that when you drop some other random thing, it becomes invalid, like this. But I can't make it so that when you drop the actual thing, it becomes invalid. Oh my god, bro. Can we permalink this? Earl? Boom. Go to permalink. Earl. There we go. I promise. line up this. Should I call it something else? Stir. Storage. Storage. Meh. To do implement the functionality of lifetime host into words. I don't know how to do this. Directly. Yeah. Okay. Permalink. Okay, I'm gonna comment. Maybe the dudes can help. What am I doing? We're going here, and then I started, I don't know, like, oh, look, I have the real song here. Get rid of the lyrics. Why are you singing over top of the boogie? Just play the song. No words. Words get out. God, it's so interesting. Such a deep tangent. In terms of Roblox, I thought Lua already has a way to hash lookup for strings. Did you say that was slow? This is not related to Lua. This is the like Rust stuff. My example of a Lua script is just one way that it can be misused. A malicious Lua script. Like I could also do that from the Rust side somehow for some reason. If I don't know, if I had like a interface to look up part properties or something, I could introduce the same vulnerability. Like that would be it would have to be like a automated brute force lookup or something in order to run into an out of memory issue, but like brute force, like there's no reason to do it. So like it's kind of a contrived example, but like it is exploitable. So what is the conceptual issue? My idea is, I guess, the idea still exists, to extend the lifetime of interesting. Very interesting, actually. Oh, I'm thinking about implementation details. Okay. My idea is to extend the lifetime of Euster to be valid for the lifetime of the cache rather than the lifetime of the borrow of the cache. That'll work. I wrote a proof of concept. No way. Here. So, the idea that I had is you can return a reference to a user instead of, excuse me, instead of user with a lifetime with a reference inside. And then the shape that the data structure is unsized and contains things. God, it's just like incredibly interesting to think about. I want to ask the library author a bunch of questions. Wait, it's the same characters. Rust, Euster. Huh. 7 months ago. What that? Aligned. Yeah, so if it's aligned, then one byte wouldn't make a huge difference. It would like waste 128 at a time or something. Yeah. Identity hasher. Very cool. If ooh. Bro. Okay, so how this library works is it grabs the like location. Okay, why are you so loud? Of a thingy, and it uses this stuff. Self.length. Wait, what? Is that a... Oh, I see. It's using... Okay, so... Look. +1. As string cache entry cast sub1. So it's going like... Oh, I see. That's how you do that. Okay, so this is a reference to a string cache entry. It takes the pointer location, says this is the data width, and it subtracts 1 as if it's an array. So it goes to the next one down. And like with, why don't we look at this in the goob here. I have a lot of, okay. So if this is the align, if this is how the data looks, So this is where the pointer points at the beginning of the string. So then a string cache entry is all of these guys. It's the hash and the length. So it says like, yes, if this is an array of string cache entries, then -1 goes to here, and that's the string cache entry. And the length is stored here, the hash is stored here. So what I'm suggesting is, what if the string cache entry is the whole thing? And it's unsized. And then wait, you'd have to do like pointer stuff. Like okay, so the goodness comes from the fact that you can grab this straight off the pointer. So that's like where does it do it? That's the Euster Aster send. Yeah, I'm being a goober here. Where's the Euster, man? Oh, what the hell? Oh, I'm in the wrong place. Okay. There it is. Okay, so Euster Aster. Look at this. So this goes like from UTF-8 unchecked. Pointer, slice from our parts. So this is making a stir slice. String slice, I guess. And this length function does that pointer. Okay, actually, no, you don't get that for free, do you? So you have to do it regardless. You got to do pointer arithmetic no matter what. So it's a fat pointer. Huh. So you gotta do it. You gotta do it. You gotta do it. You can't. C-char. Goodness gravy. So you always do this. You always pay the very small cost of doing some pointer arithmetic. So it would be fine to add, to make this thing unsized and what? Hide the pointer arithmetic and iterators. What? Oh. I see. Align. Real not true. I see. Char. So char. Wait. 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 Oh. Oh. Oh, right. Yeah. Okay. Yeah. Yeah. Okay. I see. I see. I think it. I don't know. I think it could be better. I think it could be better. I think this is like dinky and it can be made better. But I don't know what the speed penalty if it's probably fairly settled in, well adjusted to optimize for speed. So what happens if you do this? Is that allowed? That is allowed, isn't it? Payload. Yeah, no, that makes sense. That makes sense. Because, like, the stir data somewhere else, you need the length and the pointer as a fat pointer in Rust for the thing to work. So the data is somewhere else. It doesn't work. You can't just, like, have it there already. Unless it's a... No, you can't do that. No, you can't do that. Rust keeps the length on the stack. Oh, no way. Isn't that cool? We know that chars are always directly after the struct in memory, because that's the way they're laid out in initialization. We know it. Why don't you just do it? Okay, so... yeah, what is that? Checked, add, expect, round up to overflowed. Damn. This is all pointery and unsafe and blah. Alright, well... Should I say we? cool. I think this is good. Gosh, I just want to like get my hands so dirty and like start implementing things and doing stuff, but this is a fundamental issue I don't know how to resolve. I like Euster, the it's all like pointery. It looks like it's made by a C programmer, and like there's FFI and stuff, so probably that's the case. I want to make it more rusty, smooth. So instead of Euster A, Euster would be unsized, and it would you would return a reference rather than. That would be like a total library like redo. Two more dudes. Oh my god, bro. Serialize. Wait, serialize? Hold up. I guess that's cool. Does it always? Okay, I don't know. Euster. Oh my god. New. String cache iter. Okay. Bump. Oh, the leaky bump allocator right here. The world's dumbest allocator. Bruh. What the tornation? Stupid system. Do not call this. Wait. No. Confusion. Okay. Are you sure that library is safe? It's tested. The unsafe it evokes. It's a trigger word. The point is to the point is not that you should never use it. The point is that it makes the scope with which there can be memory safety issues way smaller. So instead of like a C program where like there could be safety problems anywhere in the whole program, anywhere, anytime, anything could go wrong, in a Rust program, if you have a memory safety issue, you know where to look. it's going to be here, or it's going to be here, or anywhere else that says unsafe. You know where to look. You know which code to pay extra special attention to, instead of like somehow paying extra special attention to all the code everywhere. So to focus is one of the benefits. So it lets you break the rules while also being explicit about where you're breaking the rules. No way. The size cannot be known at compile time. Do not call this. Oh my god, bro. The world's dumbest allocator. It's tiny. Allocates a new chunk. So what would it be doing? New pointer sub num bytes. Layout align. Round down to alignment. E. Start. Okay, so leaky bumpy Alec. Where does it new? Capacity alignment. Start. System Alec layout. Where layout size what this doing? Size capacity new. Who did this? So it makes a new one. Okay, I think I get it a little bit. So it's like making a new one every single time. And it goes boop, 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 every time you add a string. The given starting capacity, yep. It's 5% faster. So it allocates 1 gigabyte. Is that a megabyte? A whole megabyte? No. Grow. Where grow? Insert. Oh. Grow. It doesn't allocate first? Oh. Oh, there we go. If our allocator was spill over, that kind of mean like, okay, there we go. There it is. Okay, I see. Yeah. Two. New capacity. I understand. I get it. It makes sense. They're trying to do simple. So that's fast. Leaky bump allocator. Let's go. Love that. Love those leaky bumps. Massive. Absolutely massive leaky bumps. Was this written perfectly? 3 years ago. Ooh, somebody made a correction. Oh, was that this? Oh my god, bro. 7 months ago. Oh, hell no. System. No way. World's dumbest allocator. Huge. So why not like get like a VEC or something, you know? And just write into that memory? How is this simpler? And you can just have like a VEC of X or something? Like, yeah, why not just have a string? Oh, I guess so that you can keep the old ones. That's why. Ah. Leaky. That's the leaky part? No. Mm-hmm. Do you really have to go that far down to do that? It's just so interesting. It's so interesting. The guts, the internals. I don't really want to use this code. I just want to like re-implement it from scratch. But I mean, it's also kind of good. I mean, it exists and it works, but it could be better. Build hasher. Phantom data. Very cool. Very cool. The worst hasher in the world. Let's go. Dot hash equals. Right. Give life time. Man. Oh, can't peel away. Clear cache. So I think this can really go quite far. What if, what are the length? Okay, how does it make it? Say I get. Give me that. Give me that. 6 years ago. You can do like from array, right? Or is it const? Wait, does it need to be const? Static. Alright. Ah. Can you just do like... Oh. You just go like this. Ah. Oh, silly goose. Okay. Is this core? Let's go. Okay. Does this have no STD? No. Never short circuit wrap mut one. No way. Try. Yo. Try. Yo. This is freaking like unstable. What? Guard. Jesus. No deeply unsafe dance. Let's go. Okay, yeah. Okay, so, instead of Euster, we can have like freaking string cache entry type business. How do we know the length? How do we get that? What happened? How do we like build the goobers? String. Slice from parts ski line. Okay. Wait. String. Oh goodness. Aha, yeah. Wrong. Hash cache. Hash into the cache. Put the hash in the cache. So I believe that there is multiple of thems, string caches, to deal with lock contention. Bah. But if you don't need to do like that, hands dirty, dirty, dirty hands, dirty hands, dirty hands. I just want to replace everything. So I said, Euster 2. Help. Did I literally just call it that? Yup. Cargo rename. Is that a real thing? Cargo rename. Haha. So yeah. What's this scuba this dubert? I don't think they would have bumped the edition number. Like there's oh my goodness, 2018. What about Euster? Interesting. 2021. Is there a MSRV? Speed. Ole mole. Time. Ooh. Why is string faster? Oh, MSRV compatibility, Miri. The license is just right there. Oh, it's BSD. Plus weird champ. Ugh. Oh, that's not that bad. Short. Oh. Yeah. Oh. All right, so I was. Should I already read it. It's 2021, right? Do these guys have a MSRV? License. MIT. Let's go. I don't. Oh, there it is. At this moment, we do not specify. Outdated version of Rust. Please open it explaining what you're doing. What are the dependencies of this guy? Byte order lazy static parking lot. Serde a hash. Byte order. I don't know what that means. Okay, so in this thing, I was doing all this stupid stuff and being all an idiot and all that. But with my new profound knowledge, oh, so interesting. Okay, so Euster is a fancy schmancy pantsy. It goes like hash, yep, and then length, and then stir, and then no trait. Get out of here. No, 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 no. So we can't use a string because it'll drop the old guys. We want like little lazy bump Alec type stuff, but string bump Alec, bro, I don't know. Oh. Okay, that makes sense. Alright. Get out of here. Get out of here, code. Okay. Okay, how does it work? I am kind of license washing right now. String cache. Alec. Old Alex. Entries. Mask. Oh, keep looking. Okay, this is... hash table thingy. Okay, so this is like manually hashing table. Interesting. thin. 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 So it wants a bunch of thin pointers. Ah. Interesting, interesting, interesting. This is an implementation detail. So entries is a list, a vector of pointers to headers, and notably, they are thin pointers. So, headers. So I could actually call it that. Initial alloc mem align. You could like rename all the bits. Right, so it's pointers so you don't have to deal with the freaking lifetime. How does it grow? How do you do that? This is different. This is the same code, isn't it? Oh, it's like tiny little bit different. Some. Can't believe how much stuff is going on. String cache entry. I'm gonna do entry header. Yep, and then we'll move this off and say okay. Oh. Smart, and then add. So yeah. Yeah. Many fewer errors. Yeah. So this is wrong. Yeah. So much pointers, man. Can't we just like use Rust, you know? Oh. What if instead of leaky bump alloc, we do vec with capacity? And then like try not to overdo it and be like, oh, don't do this if it goes away. Oh, actually, well, hold on. We could do boxed slice. Right? Is that better? So leaky bump alloc, we could do better, right? We could go like, oh no, and then it dies. Do like boxed slice alloc, right? Totally. Layout start and pointer. I'm trying to like simplify it to use less of this character. But oh, rust, boxed, slice. How would I initialize a boxed slice? Collect. Reserve exact. The conversion should be 0 cost. I want to just like make it. Wait. Oh, hold up. Alloc? I mean, but then you're using a goddamn allocator. Like we could literally do like sneaky bump alloc. Let's read this. Sounds cool. When winding a bump allocator, always bump downward. More efficient. Let's go. Last in, first out. Mm-hmm. 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 I've carefully avoided saying whether it's incremented or decremented. Shouldn't do. Upwards. Low end. Okay. Why? Alignment. We need to round up. Hmm. Oh. I can't read this. Three conditional branches. Bumping downwards. Mm-hmm. Round down. Only two. Really? Fewer registers. Hmm. 11 instructions. 13 instructions. Bumbalo. Bumbalo, bumbalo, bumbalo. Bump allocation arena. Bumpalo. Ah. Do you think it'd be better to use a... I mean, I guess that's the point of the bump alloc thing. Like, look at this. 80 lines of code. Whereas Bumpalo it's much more. It's much more. That's much more. That's much more. There's mostly comments. Always bump down. But what if we grab a boxed slice? How do I directly allocate a boxed slice in Rust? Directly with skip vec. See, this is from vec, idiomatic way, into boxed slice with uninitialized memory. New uninit slice. From a fixed size array. So the problem is it's not fixed size. We must initialize each element. We must stay focused. I mean, surely we don't actually need to, right? New uninit slice. Is that real? Can you do that actual? Let's see. Bump. I don't know. So then we go like, oh, I'm a bump allocator. Let's go. Do I even need that? Like, layout. So, oh, what is that? Who did this? Plus equals. Why? Oh, I guess it's like free. Free real estate. What is that? Like it's never read from. It's only written to. I guess that's for like tests. Toto. Alright, so we want something like this. Align 128. Num entries. Oh. Surely. Yeah, I see. So crazy, so crazy. mask. So let's go with you can't do that. Bump box. We'll just call it like that or something. I don't know. Game? What? Syntax. Real? Is this a keyword? It's a keyword. Why is that a keyword? Yeah, I guess if you do it like this, then like it's always checked. Cuz you get the length and stuff. And then if you don't use pointers, then you have to like add. Yeah. Okay, what I wanted to find out was, can you make a thing? From raw. That's gotta be unsafe. New uninit slice. A new boxed slice with uninitialized contents. Is that unsafe? Holy. Mem maybe uninit. Assume init. Do you gotta do like that? Is it the wrong type? How do you how do you do a pointer? That's insane. Maybe on a net. IZ. So we got like UB here. Let's go. Into raw with allocator. Why does it? we carefully get the raw pointer out in a way that Miri's aliasing model understands what is happening. We want no aliasing requirements. Oh my god, bro. Consumes the box, returning a wrapped raw pointer and the allocator. The pointer will be properly aligned on null. The caller is responsible for the memory previously managed by the box into raw. Oh, I see. Should properly destroy and release memory. Okay, so it's like into raw, not like I'm gonna allocate. It's like I have an allocator. Raw vec with capacity into box. Oh. I want it to be more rusty, you know? I just want to have less pointers everywhere. Don't do that. Leaky. Oh. So convert these to those. So it doesn't want a reference because then it's a self-referential data structure. And those are hard. I like this. How it like owns its old allocations. Gosh. Just endless, endless thinking. Leaky bump Alec. Making me think, man. Leaky bump Alec. What if I just kind of smash together something awful and then see what's up? I don't know. I don't know. Um, a line. So it has to know like a line, right? So the point is that this guy knows memory layout and does so. Buh. Is, I guess we can go like because like you could pretend it's one type transmuted into another. This is from raw in. New unchecked. New unchecked. What? Precondition. I'm trying to break into the low level, you know. Hey. Where does it do that layout here? With capacity. With capacity. Try allocate layout. Where did you get that? all up. Layout. The what? How did he do that? This function go. Oh, there it is. T layout. T layout. Sized type properties. Ah, what the hell? Layout new self. T. So T is what? A thing that has size layout, size type properties. This is a trait. Nice. Sized. So if you got a sized something, then it has a layout. Layout new. Const. God damn. So, okay, so you gotta bring this trait in scope if that's even possible. Mem size type properties. It says it's public, so you can just kind of do that, and you got it. T. Bro, I don't know, man. It needs to be aligned to the header thing, but it also needs to be bytes. Is that real? Capacity. No, it always goes down. So, what do you want? Position, okay. So that'll do that. But it's also bad because the alignment is bad. And also it's bad because this is relative to the start instead of being just a pointer. You can skip calculations. And also this is bad. Everything's bad. I'm bad. Why do I need an allocator? Like, right, it's because you can't drop the old allocations. So like, you can't have it be backed by a string. Because then the old strings would get dropped. I suck at this. I suck. But that's kind of the point. That's why I'm trying to work through it. Like this code to me, it looks like manual everything. Like it just looks like C. It's like C with a little bit of care. System. Oh. The dumbest allocator. World's dumbest allocator. So we have to check it ahead of time. And then check it again, or what? Like, I keep trying to make it simpler, and it's like, oh, that would take an extra add. You have to add the usize to the thing. Or do you? Well, yeah. Double. Why is it double? What is mask? I'm a confused man. Capacity. So it's all ones. I'm assuming this is a power of 2. Tough. 16? I guess it's 128 gigabytes. Yo. I don't understand. I am assuming that this is like a hash table implementation. Mask. Mask is the capacity minus 1. So some kind of bits. Okay, so I see. So it's like it points to a location. Do you rehash every time you bump it up? So this is literally dist. Why is it double? Okay, it doesn't double. It pause. It's going up quadratically. Why are you going up quadratically? So it'll circulate. Why? Why is that good? So it goes up by 1, it goes up by 2, it goes up by 3, it goes up by 4. Why? I don't know about hash tables and stuff. But a mutable reference to a mutable pointer. Hooray. We know it's in bounds because it's anded with the mask. It's good, it's good, it's good, it's good, it's good. DDD for the null byte. So it's checking, pre-checking. Mem replace. Okay, yeah. Oh. 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 Oh, it's pointers. Okay. So it's not searching through the heap. It's, well, I mean, it is, but like, so it's searching through this entries. Huh. So it's a more space, but it's not thrown away. It's just new empty space that's good to go. I see. I didn't understand that previously. I thought that it was taking the thing and copying it like a string. So you would only get a little bit of new space, but you get a lot of new space. That's pretty cool. Pointer. It's very C-like. Pointer, pointer, pointer. I say that, but I've never actually written C, so how would I know? How I imagine things that are C-like go. Anytime I see this guy, I'm like, oh, it's C. Pointer. Pointer. Buh. Okay, I see, I see, I see. How would I do that? I don't see a more rusty way to do the stuff. Well, I mean, like, hash map to pointers? It's a manual hash map. What if I just use a hash map? Can you have fat raw pointers? No, right? What if you do like this? Excuse me, sir. What the actual thin type mismatch? Interesting. Thin. Huh. So you can actually have fat raw pointers. Okay, what did he say? Creates a null mutable raw pointer. This function is equivalent to 0 initializing the pointer. The resulting pointer has the address 0. No way. It didn't say anything about the provenance. Bro, I don't know what that is. I don't want to read about that. What a goofy word. Oh yeah, have you checked the provenance of your pointer? Oh my god, bro. Okay, so I don't see a better way to do this than using a pointer, but what about a hash map right here? Just go like pre-hash the hash map. Num entries. Yeah. Plus girl. Okay, I'm developing my understanding. So, what about we would have the header. We're gonna have header. Whoa, struct. I don't know, and then go like these guys. Oh, these guys go like this, and then header, and then do like this. Vec Alex. Yeah. And then this is like that. But then this is like, we don't need all that. We can do like hash map. that type of business. What's going on over here? They do hash. Boom, build hasher. Euster map. It's this guy, right? Oh, not quite. Oh, oh. Oh, is that circular? Hmm. Is this public? Is this public? Euster hash. Identity. It is. So you could potentially. Oh. Huh. Hmm. Think. Pre-duted hash. Asha. Why? Oh. The worst hasher in the world. Ooh. Oh. Would that be allowed? Oh. Insert. Insert a goober with its hash. I mean, you have all the information. So you can make one. Ash. So we're doing kind of like this. But a little bit different. Byte order. Why do we need byte order? For bytes, byte order bytes from. Can we do like from knee bytes? Oh, so basically it's just exactly the same. Except completely different. Because in this guy, it's unsized and we use freaking references. Get out of here, unless you got a reference. Split it up. Hash cache. Use that hash. Use that cache. So what does this guy want? Use create. Right. Use stir. That one. Do it. Great. And then this guy is STD collections hash map. No way. Oh, look at that. Hasha. The hasha. So instead of do like this, we should just be able to do use64 read from native Indian bytes dot try into unwrap. Huge. When did this happen? Oh, goodness gravy. Why is that laggy? Stop it. Eight. Wow, it's the world's worst hasher. No way. The hasher and the cacher. Oh goodness. Yeah. Oh. The self-referential lifetimes. Ooh. So like, may as well have a real thing here as well. Wait. it hashes to itself. I forget why. It hashes to itself. So the input is some kind of that is so interesting. That is so interesting. I'm like unfurling the structure. Ooh. So what's the big idea? The idea is that you have some sort of manually constructed uster, and then you find the one in the cache based on that one. So it hashes to itself. Gosh, that's so interesting. That was pretty unclear with the way that it was written. I think this is already problematic, but it's a very interesting signature. Option, because it could. Well, no, actually, wait. Oh, you don't need the option anymore. It's guaranteed to. Well, you just have to insert it. That's it. So interesting. Hmm. Huh. Allocator. So the allocator. Wait. So allocator equals global. Alloc. It is actually there. So, okay, I see. So the allocator is zero size type. I understand. I was curious about that. I was like, doesn't that add to the size of the object? But it does not, because this guy, look at that, zero size type. Gosh. Damn. Unique. Owns. Huh. Hmm. That's so interesting. Okay, so string cache. Oh. Um. Yeah, lazy bump allocator. Whoa. Oof. Get. Holy smoking. Okay, so then that is just self. And, um, like that. And then, do we have to? It needs, I don't know, length. That's a specific layout. I So in the other one, it has that as well, right? There's get hash string, so we know the length. Oh. So, I mean, that's effectively the same because we have hash, stir, and length. But it's like different. So we return a stir, you stir. Optional. So interesting. So do like this. Go like, wait, mutable reference. Oh, hell nah. Get out of here. We don't do like that. Okay, yeah, there you go. That's how you do it. Get exists, trait bounds were not satisfied, ecache. Yeah. I believe this is how that works. And then intern. So Um, oh. I wonder if it could actually be a hash set. Cause like, that's how it works, right? Hash set. Right. Oh. Dude. So leaky alloc is like we could actually like abstract it a little. We could say like alloc is A, and then we say cool, and then it's simpler. A never A it does something. It does something. So organize it better. But like it's literally just a hash table but different. Cache, hash, hash. Cache the hash the cache. So what else can we do here? Hash. So we don't need a lock. Oof. I don't actually know how to work with this stuff. Oh, I know how to do it. Be like that. Dref. Whatever. Bruh. What the hell? Hash. Alright, so turns out we probably want something less annoying. Oh crap. No, I can't. Okay, actually, you can't do that. Interesting. Dref. Dref. Gosh, I don't know how to do this. Let me just say this. So it said cannot be known at compile time. Statically known size. Yeah. This field is private. Shut up. Piece of candy. So let's do this idiot way of doing things. Okay. Cannot be known at compile time. Statically known size. Right. So we want like box new? Right, is that how you do it? I forget. Box stir. Private. Shut up. I don't actually know how to make these things. Oh. So interesting. So does it have to T? No. Why does it still say that then? Okay, structs must have a statically known size to be initialized. Okay. That sucks. So then how do you do it? Oof. Oof. Unsafe. Where? Generic over. Coerce or reference. Slice from raw parts. Box. Get out of here. Today, 5 years. Does it have to be generic? Like this is stack. Oh, silly bites. All right, transmute. Oof. Okay, here we go. Uh. Vec new. We do like this. Golly. Bytes. Yeah, and then you do push. Where's the hashing hasher? Do it. So first is hash, as bytes. Oh, 2 B E bytes, and then that's not quite right. extend from slice, and then coerce. No, oh, I can do like this. GG. Okay, and then that's the hash bytes, and then we do the or wait, do we want native endingness? And then we do string dot length to native endian bytes, and then we do bytes dot extend from slice once again, string dot as bytes, and then we go like bytes dot into boxed slice. No, yes, and then we do boxed equals like that, and then we do like trans beautiful. Haha. Box Eastern. Surely I've done it. Oh, the old unsafe classic. Haha, yes. So super good. Hell yeah, I did it. Let's go. And then so we have one of these for sure, definitely for sure. Well, and all we had to do was this. Why don't I make a little method here? New boxed or something? I don't know. I just am trying to like see, you know? I'm just trying to see stuff. See what happens. What happens when you do this? Bruh. Alright, so the idea is to do the impulse. So we go like, hey man, you got the hash. We can find that from existing. Oh, that's wrong. Is it in lib? It's gotta be. As ref partial eq. Oh my goodness. That's a lot of implementations. Send sync. So I think we might not like this. Oh, is it derived? Hold up. Can you do that? Is that real? I feel like it's not gonna like that. Oh goodness. Really? I don't know if we need that. Okay, so definitely need some methods here. So I don't think we need that right now. What's up? Private method? No. Hash. Okay, so then this guy's like, oh, what's up? I'm hash. And then over here, this is dumb. Ord. Partial ord. We're totally gonna need those. Where is like... Oh, Baba Booey. So yeah, my stuff was dumb. Is it mut or const? I think it's const. Stir as stir. Surely. Oh, did I do that? Oh. Mut. Okay, it's like non-null. That's right. It was something else. Scoobert, Dubert. Get. Okay, we're back to a real implementation. Okay, so where is more stuff? Eek! Oh, look at that! You just do it, and it's like, hey, couldn't you just derive that? Like, what? Hmm. Okay. Keep going. Hash. Yeah, I wanted to see that. Where's hash? You stir. From stir. So we can't actually do that. Default. Hash. Can we do better? Can we say like implement hash where the hasher is like special guy? Hash hasher does that have a associated ding dong here? No. So can I not do like only for a specific one? Whatever. Let's just keep going. Okay, insert. Borrow box. Ayo? What do you mean borrow box? know. Borrow box. Um. Get. Is that allowed? Cannot be dereferenced. Okay. Alright. Alright, well, we can test the library now. So, what went wrong? Oh no. Hash length string. Okay, so it passed these things. Oh my god. You goob. Okay, well, that wasn't too bad. Very, very, very basic. Very, very, very basic. Ooh. Is never used. You know it's it's not public. Oh. No, no, no. Optional. We'll do that later. I'm making it better. It's gonna be better. It's gonna be my way. Surely, right? Surely it's gonna be better. Definitely. Definitely. For sure, for sure. Cache hash. Oh my goodness. Yeah. I'll open it up. Uster local. No way. Why does it have to be a different license? I hate spaces. Why is there spaces in code? That's stupid. Wait, aren't we supposed to like big fat inline this stuff? Okay, so yeah. Oh, we're gonna want to do this a little bit different. Do like this. Something like that. Alright, there's no like goofy. I mean, this is pretty goofy, but whatever. We got stuff. And then I can do like stuff, I guess. Okay. We got get. Get. So I have very little to show, but it is something. Dope. String cache. There's got to be a better way. This is stupid. There's got to be like a function that means that exactly. Oh. Oh, you goober. Guess we could do that. Say this is A, and then say this is a never drop leaky bump Alec. Something dumb like that. God, this is so cool. Like, condense everything. And it's owned. You own it. String cache. Ugh. And then we could do more. Imagine. Imagine not doing it this way. Couldn't be me. Okay, I had the header stuff. That was for the alignment. Can I get rid of this for now? Leaky Bombalic. Euster. So, like, the Eusters were already referencey, but now it's just, made proper, I guess. I don't like that. Like, why are you doing it like that? It should frickin' die instantly. If that's not the case. Like this, right? Because we got try into unwrap. Panic. It's very funny. Box. You know what? I'm gonna do it. Frumster. I mean, it's not really Frumster, because Frumster is like parse. Boom. Oops, 2. Wait. Oh. You need this guy? Something like that? Yeah, okay. Wait. Oh, it's Hasher, isn't it? Does this guy get... Oh, I see. Very cool, very cool. I don't know if there's a better way to do this, but at least the code is now deduplicated. Unsafe. No way. Saved. Thumbs, hold my beer. Wait, can we do like box? There's got it's gotta be right? Gotta be. But I think this is better. So box uninit slice of the bytes. And then we go like bytes 08 copy from slice. And then we do bytes 816 also copy from slice. And then the rest of them's surely. Okay, it's actually like this. 16, boom, and then copy from slice, and then bytes, assume init. Maybe an init. Maybe an init. Crappy. It's like just marginally better to do it this way. I guess. Uninit. Oh my god, bro. Right? Is that real? Can you write? How is that even close to the word right? Okay. Can I go like... No. Rust. Copy from slice into maybe on init. Hell is that? That's somebody's crate? On init. Yeah. Yeah. So they ended up using a crate. I assume this is a bad idea. Oh. I see. Oh, you still gotta... Slice. Alright. Alright. Never mind. Just leave it be. Does it work? Did I do it? Oh geez. Oh. Oh, no, that's not good, is it? No, 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 no. I actually can't do this. I see, I see. Um, yeah. So I'm gonna need like a anonymous or a private function. So like so anonymous yeah. So it's an anonymous ooh ooh ah ah. Instead of like being owned by some guy. It's an anonymous user that is not owned by a string cache. So I can actually get rid of this. Oh. There we go. Alright, what do you want? Bro, it's used in the test. Oh my god, bro. Alright, buddy. Okay. Should just go in hash? I could like just move the function. I don't know if it's gonna be useful later, so I'll move it. Ah, jeez. Yeah. I mean, not the best code. I don't think that should be public. Oh dear, why did that do that? I'm super, super, super like this. Having Euster as an unsized type. Oh. the length is in the pointer. Hmm. So you have to have the length in the thing, because that's where it comes from. It comes from there. But we can read it off the pointer. So why is length second? That's what I'd like to know. I'm wondering if it's because so it's like next to this. Is there a reason? Because like if we put length over here, then we can omit it from the reference thingamabob, and then the length is known by the fat pointer, and it's just kind of implicit throughout the Rust code, and it's also on the stack. Well, I guess it's on the stack anyways. Wait a second. Wait a second. I have just uncovered something interesting. So, I think we actually don't need to store the lengths. Because in my little guy over here, wrong thing. Oh, we gotta go to the thing. Hold up. Good. Okay. Right here, if we're looking at this, the Euster set has a fat pointer on it. Off rip. So this is where we get the thing from. So we can really like shrink this data to just have the hash and the string itself, and also cut off the C string null character. Who needs that? Can have like a crate feature or something. And so because the fattest pointer is here, this guy knows the length of the string in the memory. So it knows. It knows. So we can actually omit the length entirely and use the power of Rust fat pointers instead of using thin pointers and C everywhere. No way. Wow. So that makes everything a little bit smaller. Everything just got a little bit better. Align. It aligns to the header. Alright, header is dumb. We don't like header. Get out of here. I don't think you can size of things good, so oh, what the hell? Omit length. Nice spelling. The fat pointer. Know the length. Period. No worry. It will know. It'll know. It changes the storage location. Do you think that could be better? Because, like, if you get the length information ahead of time, then that's, you can, like, read better. I don't know. I don't know. I would need to benchmark, and I'm not a huge nerd for benchmarks. I like theory. Like, in theory, this should be faster, and then it's good enough for me, and I don't look at it again. Wow. Coerce. You can deref. It's deref, right? Yeah, deref target. Impl deref. That's not right. Or Euster. Type. What? Oh, you gotta core ops. Type target equals to stir. Function. Yep. 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 We could do this. Why do you have to inline everything? Like, it should be default that it's able to inline across module. I wonder if it's like compile speed is bad. I don't know, but like it just makes everything better. Like, what? Deref. Holy. Looking at this code makes me dizzy. There's too much C going on. Ooh. It should be generic across the hasher. I think it could be done. It can be done. What's up with this? Oh, that's right. I did the Gubert on here. Yeah, you know how it is. Next. Now we just need to fill up those bytes in a way that doesn't suck. Leaky bump, Alec. So leaky. So why is this? Why? Shouldn't you, like, one and done, and then don't? Alec. Like, you can just do the pointer arithmetic, man. Oh my god, bro. Why does Alec need the layout? I guess so it's like stateless. But I mean, like, you're literally allocating memory that is as stateful as you can get. Please give me a giant state. I want my memory allocator to be stateless. It's the world's dumbest allocator. I just want to check manually. This thing is crazy. How come it doesn't like this? Required by a bound. Borrow is not satisfied. Borrow box Euster. borrow. So what, we want to look at like box borrow? Sized. I mean, this looks good, right? We want borrow T is implemented for any box T, and T does not have to be sized. I don't get it. Why doesn't it want that? Oh, reference borrow. Wait, what? Do you need that for this guy as well? No. What? So this one is dereferencing, and the other one is using like borrow something. Deref. Nope. Deref. What type do you think it goes to? Ooh. Is that allowed? Cool. I don't understand. I don't understand why you can't do this. Asref. Hold on, can we do like this? No, because it's dropped. That makes sense. What about like this? Now, why is it like that? I have no idea why it accepts that. That's pretty wacky. Oh. Is that... There's no way it's like... static, right? That would be dummy. I was stupid. We wouldn't want that. Ugh. I don't know why this likes this, but whatever you say, boss. Um, GG. Dude, there's like there's a lot of like unfurling of all of the C semantics to try to get something rusty. I think it's going great. I still need an allocator. And I don't know how to make that super good. Yeah, because like I can't use a vec because it drops the old allocations. I just need to keep accumulating more and more. So I can't really see a way to unsee, like the language C, unseeify the leaky bump allocator, because all of the Rust automatic allocator stuff drops the old allocation. We don't want that. Don't want that. No, no, no. Is there a data structure in the Rust standard library that does not drop previous allocations? Grows, but does not drop previous allocations. Fucking friends. No. Typed arena bumpalo. Yeah. So allocated linearly. Very fast. Very, very quick. Why is it a vec as an example? Never remove elements. Yeah, so this is more rusty, you know. Okay, so this is like a linear bump allocator. Allocate it. What does it mean to allocate memory linearly? Does that mean like you allocate the same size chunks every time instead of growing? That's my assumption. A linear allocator cannot free. Okay, okay, no. Okay, this is the bump allocator is a linear allocator because it allocates linearly. Okay, I see. Okay, I see. So it's not that it has no growth factor. It's that the each new allocation is just the next available spot in the memory. Okay. Okay. I mean, this thing kind of looks like I can just go like, cool, and then that's it. Never freed individually. Let's look at it again. So they have like vec stuff here, but we don't want that. Well, let's read up top. What did it say? A fast bump allocation arena for Rust. Limited approach to chunk of memory, maintaining a pointer of that memory. Whenever we allocate an object, we do a quick check that we have enough capacity left. Then update the pointer. Yep. No general deallocate. Yep. Phase. Deallocated together. Yeah. Let's start with this guy, because, like, if I need to, I can, like, do better. Let's try. So surely it just works, right? Then we do like this. New. Self. Yep. String cache. Can you imagine if it's this easy? Can you imagine? Why did that happen? Go away. Oh my god, bro. Alright, Alec. Oh. Slice clone. Slice fill clone. Alex slice clone. So we don't actually need a slice. Alex stir. Try Alec. T. So T is sized. Okay, so I think let's do slice, copy, and then we can do uster as bytes. Oh, but we can't do that because that's only the string bytes. That's a deref. Naughty, naughty. Damn. So we want the header there as well. Hee hee. Yeah, so this is a little bit how about as bytes with header or something? As full bytes. I mean, it's still not obvious. As bytes. So it's like, so if you do as bytes on an outside thing, you probably want the string. So it's going through deref as stir, but we want like oh. How does it work in this guy? Wait. Oh goodness. Oh goodness. Oh goodness. I found them all. Okay. Okay, so we want a function called like as slice. Is that a real thing? Hold up. Yeah, so stir. Oh, no method named as slice. Okay, what if I make this go away? So it says no method found for as slice. As bytes slice. But like, be specific. As Euster bytes. Let's say as Euster bytes. Because then that's like, oh, it does everything, right? As Euster bytes, and it's just like, hey, I'm the bytes, and then we can just transmute. Surely, except this is unsafe. God, I love unsafe code. Okay. So, insert that sucker to death. So that comes off of this reference. Damn. So it's mutable reference, but we immediately don't want that. I don't know what to do. I love this function. Transmute that sucker to death. Hmm. Ooh! Oh, cell none? No, cell? What is a cell? What does it do with the cell? Cell. Why cell? Unsafe cell. Okay, no drops. Will never have their drop called unless you do it. This makes it easy to leak memory. Even if you drop the allocator. Destructors are never guaranteed to run. What? Oh. Is this not what I think it is? Never drop. Hot damn. Is there drop actually? Lib. Drop. D. Alec. Okay, I think I see. Okay, destructor. Okay. Right. I don't actually need that. Okay. So, this is fine. So, it says the destructor will never be called, but that does not mean that the memory will never be freed. It does free the memory, it just doesn't call the destructors. And that's exactly what I want. That's exactly what I want. So it puts the thing in the thing, and there's the thing, and then the memory is freed when the allocator is destroyed or when the string cache is destroyed. Amazing. But it doesn't need to call the destructors because it only ever gives out references to the objects. And then the idea is that those references are invalid when the string cache is dropped. But I don't know how to implement that yet. So, yeah. But look at how small it is. Yeah. Oh, wait. Oh, I see. Let's go. This is interesting that it likes the lifetimes on this, which is different than how it was before. Is there more methods like get rid of me reference? As ref. As dref. Dref. Oh, I see. Okay, I see. That's why that doesn't work. Okay. That type signature was very clear. Okay. So it doesn't have a thing. Oh, copied. Oh, that's it. Gaming. Big, massive gaming. Okay. That's the one. Yeah. Oh. Not quite. Not quite. These guys have got to be strings. Oh, public. Oh, interesting. So what I have to do is make an anonymous user. I see. on the stack, but I can't do that when it's together. Crap, crap, crap. So close. Actually, it knows here, doesn't it? Transmute, transmute, transmute. Okay, so I'm seeing a problem here. Yeah. Close. Dude. All of that. 23. 23. Oh, dude, it's 0 dependencies. That's nutty. How many total? Unicode. Sin. Where is he coming from? Which? Oh, a hash. Well, yeah, okay. I guess it's a friggin' hash guy. Bumpalo. We're liking I'm liking Bumpalo. Bumpalo. Very nice. I'm pretty sure it just does exactly the same thing as this, except it's like maintained. Holy moly. Oops. Why did it think that? Why does it be doing like that? This file is not included anywhere. Press X to doubt. Oh, there it is. Okay. So I could go like pass the hash around on the stack. That would work. It's not the way. I think I just need to make the interface more complicated. So basically the problem is this needs to be stir right here. And then I need to construct either an anonymous user, but like without allocating. So that's why you need your own hash table, is so that you can go off of the stuff. So let's use the silly function from the silly guy, just to do a quickly get it done. So I did need it after all. Use create user. No. Where did it go? So then right here, all we need to do yep. No! It went too far! Oh, wait. Wait. Oh, wrong argument. You goob. Big goop. Okay. What up? Stir. Oh. Oh. What is it called on the other one? String. Okay. So this is bad. I'm dummy. What's going on? Oh no, that's good. Okay. Oh why not, right? Inline everything. No reason not to. It'll just not do it if it's a bad idea. Okay, so this is an allocation, which is basically the entire point of the library to avoid. to do a void allocation. Oop. Okay. So I can take my testing guy from over here. So test. Forgot. Okay. Okay. So firstly, string cache new, and then I guess, yeah. Ooh. Gamering. So once again, it doesn't know what it's doing. But I mean, it should work. Why didn't that work? Distinguished. Bad. Oh my god, bro. So we have failed the test. We interned a string, and it did not get interned. Huh? Huh? Okay, it says partial equals. Huh? Ugh. How many lines of code did I go? It doesn't work, I guess. What is the thing? One fetch. 151 lines of code. I can't believe my idea were. I mean, I guess it's not. Yeah, okay, it doesn't own it. Skookum dookum though. Whoa, 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 wait. Wait. Hold up. Unwrap and well, oh, it's that. Okay. I'm gonna actually blast this up to my GitHub. Oh, I don't have a license. It don't be working. That's okay. I'll just send it. Local string interning based on Easter, but with less pointers. Fewer? Neato. Surely. Let's go. README. So true, so true. How do you do README? Copy. Ooh. It knew something was up. Alright, what does this look like? Okay, convert files. Okay, so, yeah, there's no such thing as a license. Get out of here. Okay, so, unique string. String internment. Simple. String internment. No way. Library using a bump allocator. When okay. So this is like grow only. Memory is freed when the cache is dropped. So I think this is true. It doesn't really pass any tests. Wait a second. Is that okay? No, because then I was thinking like, what if there's a macro, anonymous ustring or something, and it just makes a compile time uster. But that's not good because it's not actually deduplicated unless the compiler can do that. Unless the compiler can guarantee with a big thumbs up that all strings are deduplicated. I guess let's see. If that's true, then like easy. Rust string literal deduplication. Oh. Dupe. Okay, not a useful page. Okay, well, that was a failure. Are string literals deduplicated in the final binary in the Rust programming language? Nice caps. Some caveats when they can be. If the exact same string literal appears in multiple places in code, most of the time the compiler will place only one copy, reuse the same pointer the string it's used, done at LLVM level, so it's subject to optimization. It's not hard guarantee on the language spec. dude, this is like Omega. This is like better than Euster. Cause like you don't need a cache. Like they're gonna be compile time anyways. Now I just have to figure out how to make it at compile time. I did not even consider that you might not need the internment thing at all. So yeah, no, this is like a global cache, but like it don't need to be doing like that. So like if you always pass around references to Eusters, you're chilling. You're literally just chilling. It's like string, but it has a pre-calculated hash. Basically, that's it. And then you can just smash it into hash things all you want. No way. So let's see. Can I make something better than this? Const. Bruh. All right. Critical thinking skills. Go. Surely. I'm not really good enough at Rust to know how to do this. What about the vec macro? Show me. From LM. Box new into vec. Doa. 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 Oh my goodness. Using the intrinsic produces a dramatic improvement in stack usage for unoptimized programs using this code path to construct lardvecs. Okay. Oh. What? No. What? Who did this? Oh goodness. Vec Who did this? Earl. Alec. Find it. Yay! Okay. Uh-oh. Oh, wait. It's not const. What? How do you do a static? Okay, let's see. Maybe, okay. Create static reference at compile time. How? Oh, Rust. Rust. Spelling. Repeat a static string. So yeah. So we could look at that. We could look at that. Let's see. So it's like std_fs read. That guy. No. That's like include bytes. That guy. Give me that. Who did this? Compiler built in. Oh my god. Oh jeez. Boy, so we gotta. All right, I give up. How can I make a static reference to this struct at compile time? Arrow. I'm just gonna like smash this like that just to make it easier. Thanks, bro. In Rust. You can directly create a static reference because it contains a str, dynamically sized type. Oh, you can't directly. Okay. Yeah, obviously. Otherwise, I would be freaking asking. No. Use a wrapper. What? Then you could create it via something like Box or something. Really? The point is to have a macro that creates static uster like such. Uster. Boom. Or const function. Full working example. No worry. While, okay, as bytes. What? Okay, hash. Okay. So that doesn't work. Literal. Oh. Yeah, no, this is dynamically sized. This is very naive. It's worth a shot. Wait, can you? Is this? No, no, okay. Hash. No. It ain't gonna work. Ain't gonna work. Oh, it freaking zoinked me. What the hell? Do it again. No. Stop. Wrong. You didn't generate the correct response. Euster must be an unsized type and not contain static stir. Do not. Oh my god. Repper C. Yeah, I don't think. Oh, no way. Must be last, I guess. Okay. Okay. Now we're talking. That makes sense. So you just kind of put a bunch of bytes in a spot, and you're like, oh, those bytes, that's a Euster. Here's a reference. Wait, length. That doesn't look allowed. Oh, literal. Oh. Huh. Byte array of a literal string. Byte array of a literal string. Interesting. So yeah, it's all like, okay, this is a much better attempt here. You can use something else if needed. I think this is actually going to be a problem, the hashing, because like, how do you hash at compile time? Do I need a proc macro? So the whole point is that like they're deduplicated at compile time. or runtime, I guess, with the string internment thing. Uh, uh, oh my god, it's a bug. Bug, oh bug, bug outside, bug. Outside. Oh jeez. It's landed. Oh. It's landed. Oh, I don't see it. Well. The bug will die in my house, unfortunately. What if there was no string internment? Euster's a macro generates static Euster two at compile time. Which contains the pre-computed hash. Build upon Immutable compile time cache. So Anonymous. DST. You still need to copy it. Um, I think this is more obvious. What the hell going on? Ah. What happened? What happened? Escapes? It don't be doing like that. Oh wait, did the function signature change? Oh, static. Wait. I see. That guy would never be freed. Remove header. I think it's better like this. Um, So there could even be no string internment whatsoever. So you have an explicit cache if you want to do stuff. You have the compile time goobers, and you can use those only yeah. Does not work. I should put that on there. It does not work. Why don't it be working? Why do it not be doing like that? So let's take a look. Why doesn't it work? Why not? Why not? Oh, unwrap. Oh my god. Oh, why would it break? Oh god. I don't have display. Quick rundown on what unwrap does. So it's a quick and dirty function. It's you generally don't want it to exist in your final code. The idea is that this is an optional value. So could I, oh, come on, show up. So there could either be some value or there is no value, none, but that's represented as a value. There's an explicit representation for there is no value. So sum is t. I don't know why it doesn't show that. Nice, real big. Okay, so t, there it is, it's t. All of this is just like macro bing bongs. So it's returning an optional value. So maybe you get a string, or maybe it doesn't exist in the cache thing, the entries. There is no entry, right? So in Rust, you must handle this. You can't just pretend it's gonna always exist and get it. Like the idea is like a null pointer, right? So in C, you could just like, you get a pointer and then you get the value, but maybe it's null. You don't know. Whereas in Rust, references are never null. They are guaranteed to be non-null. So this is like a rusty pointer, kind of. It catches errors. Yes, but there's more to it. There's a whole ideology surrounding it. The idea is to accurately model your data. So if you have a reference that can never be null, then that's a reference. That's a normal reference. But if you have something that could possibly be null, then that's an optional reference. Or maybe it's very, very useful to model data, this option type. So by saying unwrap, I'm saying I don't care if the value doesn't exist, crash the program. Just give me what it is. Quick and dirty, give it to me. I need to use it in the code now. So this type here is option, and then unwrap, give it to me. Give to me your reference. Oh, where can we look for more stuff? Bruh. Oh my god, bro. Option. Graphics. Option hit. So I'm like, it's the types are algebraic. So you can compose a struct inside of an enum and an enum inside of a struct as much as you want. So this is saying it's an optional value of a tuple of two types. Here's another optional reference. Option byte. So this is like, okay, so here's a well-modeled piece of data. What is the jump limit? Well, maybe there's no jump limit. Maybe there's none. Or maybe there is a jump limit. Maybe it's 1, 2, 3. Maybe it's 0. Maybe you're allowed to jump 0 times, or it goes up to 255. And like, you don't really need values bigger than that. So it's modeling the precise semantics of what happens, because a 0 jump limit is not the same as there is no jump limit, and a 255 jump limit is not the same as there is no jump limit, right? So it's a tool to precisely model your data. It's a common representation of data structures, and it just so happens to be excellent for null pointers. This is not a pointer here. It doesn't have to be a pointer. It's an algebraic type. It can contain anything. It's an enum, which is exclusively none or some. You can't have both because it's not a struct. Like, you can't set the none value and set the sum value. It's one or the other. Precision data modeling. Did I have other things I was going to say? There's a whole ideology. Right. Okay, so you might think, oh, that's kind of like true false. Like that's more data. So do you need the bool value and the pointer at the same time? No, because it can represent it since a reference is known to be not 0, it can special case the 0 value in memory as the none value of the optional value. So it is actually able to have the same size as a like C pointer, but have this like very elegant semantics to represent it explicitly, and force you to consider the possibility that it is null when you model your data that way. It's like setting up your own rules of how you expect the data to work, and then following your own rules. It's following your own rules. Like, you don't have to say it's an optional value, and references are convenient in that they are always non-null, and you can make lots of assumptions and have very few errors and mistakes, right? But if you need that, then you can model that for free. Zero cost abstraction. Rust is just absolutely packed with these careful considerations of data modeling and like explicit handling and stuff like that. .rs. Yes. I have this cool thing going on here. So I was looking at uString, uster, the fast FFI friendly string interning library. And so the idea is that you make a uster and it checks to see if it's already been created for. And if it has been created, it returns you that one. Otherwise, it creates a new one. So it's deduplication. But it's all like global state and like you can't ever drop them. And there's no way to do it at compile time. And like it's full of foot guns because like if you just keep making usters, if there's some part of your program that has user input or something, it'll just like memory leak over time. And like this is part of a library that I was using. They started using it internally, and then I had to change my code, and I shot myself in the foot like 5 separate times. And so I went and complained about it. I'm like, actually, I have some complaints about this library, but it has gripped me ever since. I'm so interested in, because it is definitely a positive. Like there's no doubt that it's an improvement to this library, but it could be better. It could be even better. And so I've been making GitHub is right here. This is the one. It doesn't work, and it's I just kind of whipped it up today. But boy, is it smaller. Like, look at it. It's 151 lines of code so far, and I'm not super sure if it is gonna do the job. But like, I think I'm onto some good stuff. It's been 8 hours. I've just been like thinking and thinking and thinking and thinking and thinking. So like, it'll memory leak if you use input, if you keep generating new strings, and then you can check if it already exists, but it's not obvious that this is happening. And then like I can use this function to make sure that I only pass string literals, and so it won't generate an infinite number of strings. But then I still managed to misuse it in my code. Where is it? What happened? Oh, it's gonna be way down here. I absolutely went crazy with this. Update. Yeah. Okay, so this is the update. So you see I'm using uster here now. So it like, you pay a cost every single time you want to do this, because it must hash the string and like generate the hash and stuff. So that could totally be done at compile time. But it's not that bad. Oh. It's a function. Huh. What was I doing? I wanted to show the shoot foot part. Use guardrail. Yes. Okay, so this was actually wrong. So I'm guardrailing against problems that I can foresee with this. And I actually did this wrong while trying not to do it wrong. Bruh. So like, right? That's like not very rusty feeling when you can actively smash your feet so often. Yeah. Okay. So this does prevent it from creating new strings, because like the uString must be existing already. This is the user input, right? So this is like a Lua script is running, and it's trying to access a property of some object, and the properties are indexed by ustrings. So if the string doesn't exist, the property doesn't exist. But it's not always trying to access a property. Sometimes it's something else. So this was actually wrong to early return. Oh, there's no semicolon. I have 15 years of Lua experience and 1 year of Rust experience. Static. Yeah, there's problem. Did I fix it like right after? Can't remember. Fix subtle Euster bugs. And I didn't explain it. God damn it. Okay, oh yes, okay. Interestingly, Euster can know ahead of time if it... Oh, yes. So the property can still exist even if the value hasn't existed yet, because there's default properties. So you have to find the default property and give that to the script if there's no value and the default property exists. Roblox is awful, but yes. And then also maybe it is a real property, but it doesn't have a value right now. And then this was wrong. Not obvious. Subtle. Yeah, and I've been diving down this rabbit hole all day. I've been thinking about it all week. There's got to be a better way. And I looked at a bunch of different string internment libraries, and like, it's not quite what I'm going for. I like the very rusty, rely entirely on the borrow checker. So no arc, no mutex, no locks, just like design the architecture of your program around the borrow checker without like having like locks and stuff. I really like not having locks. I haven't really seen something that needs it yet. I'm sure there's stuff like this is actually something that Euster is something that is a very obvious benefit and is rather complicated based on compared to the sort of rusty way that I mentioned of like just mutable and immutable references, pure raw safe Rust. There's a good reason to do it. And so dive down that rabbit hole. See where it leads. I made a proof of concept here earlier because I couldn't figure out how to get the storage or get the lifetimes of the returned objects to become invalid when you drop the value. I want so you say get string and it gives you a string. I want this lifetime to end here when you drop the words. The words. And I can do that using a lifetime host. So if I drop this, it goes compile error. You borrowed it here and then you dropped it, then you tried to use it after. I want that right here, but I don't know how to do that. But so I had a good idea. I had like I was reading the code a lot from the Euster library, and I have very small implementation here. 151 lines of code, including tests. I think it's better. There's no global thingy-mabob. You may not even need a cache at all. It's better. I don't actually know if this worked. What would... I think it did work. I'm pretty sure it did work. I'm just going to assume it worked. And if it didn't work, unlucky. Oh, did we ever see this? Oh. Okay, test release. How do you do it? No capture. Ooh! That doesn't look right. Cruh. Oh! I have actually just realized why. It's because I'm writing the length, and I removed that. Unsafe. Remove header. Remove... Did I... That's all the way down here. Oh. Stuff. Omit length. Oops. All right, let's see if it works. No. Where did the print go? Oh, it's not real. Shra. Okay, so it's still UB. Shouldn't it work? Yeah, that's definitely UB. It's probably UB the moment it comes out of here. So let's see. Hash it. Okay. Let's print here as well. You too. No way. What? Oh. Why is that okay? Is it the repper? I have a feeling we can't repper. Oh no, it likes it. No. So these ones work. I thought it was
this thing. So it was both. So it's got to be this thing transmute here. Reference to a user, mutable bytes. Alex slice copy. Copy a slice and return an exclusive reference to the copy. Why do it be doing like that? Here, let's go like... why don't we implement display? Oh, geez. Oh, type must be known. Shut the up. Oh my god, bro. Oh. Display. Display. Oh, how do you... Can you... Okay. F dot... Right stir. Do it. Surely. Oh, and we need one of those. Let's go. Okay. GG. Okay. So now we can do cool people stuff. Display. Go. I don't know. Yeah, I don't know. Okay, so let's do this. It never run? Shouldn't it have gone here? Oh. Oh. Okay. So that guy is bad. We can do like this actually, because now we have display. Yay. So this one is like GG, and then this one is like no bueno. Did it work? I think it's may at some point. You may. So why does it not be doing like that? This just goes like, hey, the bytes? Yeah, make those bytes. and then goes back into it. So, huh? This is just some mutable reference to some bytes. So how did we go from all good, man, to no, when it's the same damn thing? What? 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 Clone a slice. Prefer copy. Copy. Did I? Why? Isn't this like a no-op? It should return the same bytes. Is this library broken? That will be bad. Is it dropping the old allocations? I don't know. Previous. While. Okay, so this is a linked list. Okay, bro. Sure thing, buddy. Okay, so it does not do that. It does not drop the memory. Okay. Why? Why does it break? I don't get it. This is a deeply, horribly unsafe function. But it's like, it's whatever. If it does the job, right? When you're transmuting, are you reinterpreting the hash and the string? So this guy, here's a reference to a Euster. Cool. So then when I do this, let's look at what it says. So we say, so Euster is a hash and a string. Cool. So this is a reference to the hash and the string. But like the underlying data, it's just a pointer to some bytes. So that's what I'm getting. I'm just getting a pointer to some bytes. Like it's a valid reference still, but to some bytes. So these bytes should have the same representation as this, because they are untouched. This is actually a no-op function. This actually does nothing in the code. It's like just totally a compile time semantical reinterpretation. Bruh. What? So if I I don't know. Let's say, hey, these are some. Hey, go away. These are some bytes. Let's do assert bytes equals assert equals new bytes. Those should be the same. Oh, that's not what. That's not good. Undo that. I just wanted to do this. So I'm thinking the bytes were the same. Because yeah, I printed this. New Euster XX. Reinterpreting the hash. I'm saying, yes, this Euster, it's just bytes. And then I copy the bytes and I'm like, yes, these bytes, they're just a Euster. So yeah. Show me them bytes. 3. So these guys, no, these guys are the hash. These guys are the bruh. That looks right. So then why are those different? Were those just different? Oh no. It's this. So this guy, why? I don't get it. It is looking like do like this is bad. So it's supposed to be a no op. So I guess we can do the reverse here. Oh. Oh my god, bro. So, yeah. So it looks like my round trip operation is not as round trip as I thought. So the bytes, the library is working great. Who did this? One. What did I do? Who did this? Oh. I see. It really needs this. So unsafe. That actually might have been why it didn't attach to lifetimes. Huh. So these were just totally separate lifetimes. Oh, it gains this guy. Oh. What? All right, what if I just prank it, and then we do this later? I don't care. What the Euster doing, bruh? Okay, so it is valid, but it was optimized into death. Yeah. You can't do like that. You can't do that. Yeah. Oh, is that honest? Okay. Why is that one okay? Wait. Hmm. Hmm. So I need this special function for special programmers. Hee hee hoo hoo. Why? Unsafe function is unsafe and requires an unsafe block. Could you guess that it's unsafe? Oh. Okay, so this is like... Okay, so that's because it's just super old? Okay, so... I am not so sure this is gonna work. Because, like, it wasn't working before. Okay, does this guy work before I make it die? No. Why? 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 I don't get it. I know it's unsafe for some reason, but it has never been my strong suit. And that's actually the entire reason why I chose Rust, is because I would have just crashed and burned C++, making my own game engine in C++. Just, I would have made every possible mistake. I would just be debugging null pointer dereferences all day long, and that just didn't sound fun to me. So I was like, well, if I do it in Rust, it's still fast, but I cannot write memory leaks constantly. And the rest is history. Very successful assumption, good assumption. I have been very productive instead of debugging memory leaks every day, all day. Buh. Hmm. 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 Brilliant. Brilliant. It's just unfortunate. Wow. You don't need a cache at all. Wow. I don't know what is going on. Does it do wrong? How do I do better? Uh, um, um, so close. Cause like it would be super convenient to be able to access the hash table with the hash and the stir rather than you must provide a user. Currently, I'm like allocating an anonymous user, so that could be moved out into the ting the collar stuff. So like anonymous user, just like generate an anonymous one with no intern stuff. Right. Okay. Actually, the idea is that you don't. Allocate. But it's only runtime because like you would do it all ahead of time at compile time with a macro. So there would be no allocation in the library. But like this, it would be still convenient to have a cache. Yeah. Cool. So I can't really think of anything else. Call it like hashed stir or something. H stir. H stir. I like H stir. Let's see. Is there a goob for it? Oof. Wait. Wait. Wait a second. Oh, JavaScript. Okay. There's no way this is just literally exactly what I'm making, right? Global store. Ugh. Oh, Adam. Ugh. Tagged value unsafe data. Why? Okay. What did he say? Cheap to clone, compare hash, and has a small size. Cached Adam. Wow. Adam has never dropped. Y'all doing any locking? What? Buh. This is goofy. I don't know what it's doing. If some unsafe data equals some other kind of unsafe data, then you're good to go. Always. Holy smokes. Oh. Well, huh. I'm copying that. Hash cache. Oh. What the hell happened? No way. I think I juiced it. Why didn't the other one you do like this? Nope. Goofy. Drop is dynamic. No way. Thin arc. What is that? No way. Bruh. There's a little bit too much going on here. Let me get simpler. Simple. So, Hter taken. Unlucky. Uh. No, then it doesn't work at all. $155 lines of code. You got me. You got me. All right. I think that's enough for today. Pretty crazy amounts of thinking. A lot of the stream, I was just sitting there and thinking. I'm thinking. But, gosh, I haven't done that in such a long time. It's a new challenge. It's something I haven't thought about before. It's deeply interesting. Fun. I'm not sure if this will like end up with a working replacement or if it even makes sense at all. Like, can you attach the lifetime of returned objects to a struct itself? You gotta be able to do it, right? Because, like, how else would the other one work where you can just borrow the thing? This guy. So this guy has the lifetime host, right? And so that's great. And if you drop the lifetime host, it's like, you can't do that. So it should be the same type of deal. Waving in it. The lifetime, the host, the cache, the bump below, the what? Oh, wait a minute. So when you do this guy, is it a beautiful self? No. So I never need mutable alloc. I do need mutable entries though. That is interesting. So I could use the alloc as yeah, no, I could say the I could totally do that. I could totally I could say this is a reference to an alloc. Too bad I can't just use the alloc trait. And that would work. And then you could even use the same allocator with multiple string caches. So this is like string host, I guess. Oh dear. So this would work. Bombalo, bombalo, bombaclat. So if we do like this, that would work. So we say, hey man, this is your allocator, man. No way. And then it's like that. And then it do like this. Stir. You good? And then it actually makes sense. Period. It actually makes sense, period. Because the string host, the string values are still valid even if you drop the string cache, but not if you drop the string. This is actually just straight up correct. It's actually straight up correct. It's a little bit squibbly, but host. Oh my god. Nice spelling. And then Yep. Hee hee hoo. Yeah, so then we go like so it ain't pretty, but this is actually correct now. So this is not UB. It's not UB. And this would be UB, but it's prevented. Better. So this is no longer UB with Alec owned by string host. Should I call it host and cache? Insanity. So what happened? D happened. Is there default? Wow. 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 Move locator to lifetime host. So you can drop the cache, but still have the strings be valid, which like that's totally valid. What if I run it now? Still broken. This is so sad. It's so much simpler than the Euster. Like, have you seen the Euster string cache here? Pad. And then like it's still fairly simple, but like this is dead simple. And then like in the library, the big guy in the sky, God himself, the string cache with 64 bins. Where is it? Who did this? Is that real? There it is. Okay, string cache. Bins. 64 bins. This has like mutex locks and stuff. Test lock? What the hell? Find it. Oh, yeah. So there's 64 bins, each with its own lock, and it does that to like minimize lock contention with multi-threading. But what if you just had a freaking cache per thread, like, and you didn't need locking? You know? Or what if you managed it yourself to optimize it for your use case instead of like automatic locks and like mutex guards and stuff? Oh, I made this better. I forgot. Should I submit this? Like, ooh. Damn. I unexpectedly stumbled upon the correct implementation. That is a certified Rust moment. I mean, it's not exactly the most easy to use ergonomic A plus API stuff, but like, what if we just didn't need it at all, you know? You know? What if you just didn't need it? Unlucky. I think we have 160 lines. It sucks, you know. 160 lines of code. It's no 150. It's like I'm going a bit overboard. Cool. So the lifetime host thing actually had a meaning in the end. If I put the allocator in that GUI, then it actually has a meaning. And this is not UB. Wow. 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 Is there like a super duper method on the thing where you can go like, oh, hash pre-done. I did it already. The hash, just get it with, but I already did it. Cause like that would be excellent. Bruh. I want to sneak past the wait. Sneak past the requirements. All I really need is something that can be partial eked with the inside value, and I can provide the hash. So I skip the requirement to pass the exact same type. I'm like, oh, here's the hash to make it fast. Here's the value you compare against. Go for it. That would be great. Oh my God. little boost at the end there. I got the lifetime host. That's really cool. That's so cool. Wow. So I can do that on the other one as well. Oh, it went away. Oh, I guess I did do that. This guy. Give me that. So if I put the storage into the lifetime host, then we're chilling. Len. I see. Interior mutability. Wait a second. Bumpalo, that's gotta have like big locks and stuff. Cell none null. That's a mutable memory location. It's interior mutability. Get. 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 What? Jesus. Const. Can I do like that as well? What if I do like that as well with this guy? Can we do like... well, like obviously not, but like... non-primitive cast. So it's like... wait. Is invalid. Yeah. I would have thought so. Yeah. I don't know. I have no idea what I'm doing. All right. Well, good enough. Learned a lot. Had a great time. Did a lot of thinking. Overall, A+ type programming day. Mint. Finger looking good. All right, I'm gonna go and cook my lobster shrimp ravioli. I think that's what it is. Hell yeah. All right. Goodbye. I'll be back tomorrow and do more something. Probably this.